We hope you are staying safe. With everything that's been happening, and we, especially as a region, have been experiencing, I think we have proved ourselves to be a resilient bunch. And we want to keep helping you to do that. And we somehow overcome no matter what comes our way. Just like this virtual summit that we're hosting for the first time in APAC. Welcome to the WSO2 Summit in APAC. We're very excited that you decided to join us. My name is Ishara Nautana. I'm the Product Marketing Manager for WSO2 Identity Server. So, identity and access management, API management, integration. How will all of these technologies help you in building an integrated API supply chain? And how can this help your enterprises become digitally transformed and help you keep helping to stay ahead with your competition? So, within these next 2 days, that's what we're going to do. We are going to be learning about these technologies, how it can help you. We'll hear from our customers, their success stories as they share their experiences, and they will tell you how they navigated through those challenges, and you will be able to learn from that. But during any point, if you have any questions, any clarifications, we are happy to help. If you're joining us from Zoom, you can go ahead and send in your questions, and our team will be happy to take them on. Or if you want to take part in the Oxygen Bar, you can do that by joining wsummit.slack.com. And we'd like to hear about your experience on Twitter as well. If you're following us on Twitter, you get a 50% discount from Manning Publications. I'll tell you about it. But if you are sharing your experience, don't forget to tweet with hashtag WSO2 Summit, hashtag integrated API supply chain, and hashtag API supply chain. So, like I said about many publications before, yes, you get a discount for following us on Twitter. But since you decided to be here today at the virtual APAC Summit hosted by WSO2, you also get to walk away with a free copy of Microservices Security in Action, co-authored by Prabhat Sirivaradhan, Deputy CTO and Vice President of Security Architecture at WSO2, and Nuan Dias, Deputy CTO and Vice President of API Management. So let's get started. To welcome all of you and to give you an overview of what you can expect for the next couple of days, I'd like to invite a powerhouse at WSO2. She's someone who always brings in energy to any room she's in. And even though behind Zoom today, I think she will do a just as decent job. Everyone, please welcome the Director of Global Outbound Sales and Enablement of WSO2, Dilani De Silva. Over to you, Dilani.
Thank you, Ishi. Good morning, good afternoon, and good evening, everyone. Welcome to our very first virtual summit for the Asia Pacific region. As Ishi mentioned, with this whole pandemic going on, we really hope that each and every one of you, along with your families, are staying safe and, of course, adjusting to the new norm. These are unforeseen times that we are living in, which I am positive that we can overcome really soon. WSO2, fortunately, has been holding ground very strongly, and during this time, in fact, we have grown in double digits, and we are set to surpass our revenue achievements of last year, 2019. All thanks to a fantastic WSO2 team spread across globally, and of course, our amazing customers who put their trust in us for their digital transformation journey. So, on that note, a quick announcement. It's quite exciting. We are super excited to announce that WSO2 was positioned as a significant leader for API Manager in the recently published Forrester Wave report a few weeks back. A free copy of this report will be shared with each and every one of you who has attended and registered the summit. So you can go ahead and share it with your colleagues as well. And if you want more information on how we got that positioning, you can always contact us as well. So just to go through the agenda, we have an amazing lineup for today with some phenomenal customer talks. We have one of Malaysia's leading telcos, Telecom Malaysia. And we also have a talk by OCBC Singapore, which was recently named the world's best consumer bank by the international publication Global Finance. Today, we will be starting our talk with our keynote about APIs being the key enabler for a successful digital transformation and enabling business agility. We will go on to discuss how APIs are the products of the 21st century. And our Chief Technology Evangelist, Asanka, will discuss on a decentralized reference architecture for cloud-native applications. We will then deep dive into how we can use integration microservices to create smart endpoints, and end the day with our IoT partner, Integra, who will provide insight on managing unified endpoints for enterprise devices. A big thank you to all our speakers, panelists, and the wonderful WSO2 team that has put this event together. Special thanks to our guest speakers today for taking the time off to be here, especially to Sivan Umapathy, who is the CIO from Telecom Malaysia, Akash Saxena, VP of API SOA Delivery at OCBC Singapore, and Sumedha Rubasinghe, the founder and CEO of Integra. Unfortunately, Anubhav Rajput, the CIO of the Indian insurance giant Chola Mandalam, could not be here today due to an urgent appointment. Okay, so for our first speaker, it is a pleasure to introduce to you our very own Mr. Calm, Cool and Collected Senior Vice President of Engineering, Selvaratnam Udayashankar. Shankar oversees WSO2's entire engineering efforts. He has been in the industry for over 15 years and has a wealth of experience in cloud computing, distributed systems, SOA architecture, security, governance, enterprise integration, and telecommunication billing systems. This is going to be a fantastic presentation as he delivers the keynote on the integrated API supply chain. So guys, sit back, relax, volume up, and enjoy the rest of the day. Over to you, Shankar.
Thank you, Dilani. It's a great privilege to be here, folks. Very good morning, good afternoon, good evening. So let me share the screen. Ishi, can you see the screen and can you hear me loud and clear?
Loud and clear, Shankar. I can see your screen as well.
Okay, let's start then. So welcome, folks. It's a pleasure to have you in this particular summit. And in today, my focus of this presentation is going to be setting the stage for the next 2 days. Obviously, I mean, some of you might be familiar with some of the topics I'm going to discuss, but I want to set the stage correct so that all the people have a understanding about the topics we are going to discuss in the next 2 days. So we will discuss about integrated API supply chain for the today and tomorrow, various topics from various parts of the supply chain. And then this particular talk will be a level setting talk for each of these topics, right? So let's start with the definition of a supply chain. So if you take a product, for example, right, in order to build a product, you need the raw materials or components, which are the source materials, and you need distributors for those source materials. Then when you produce the product, you need a distribution channel where you will the distributors will take your product and then distribute to the customers to consume it. So basically, the supply chain means the network between the company and its suppliers or distributors to produce and distribute the products to the final buyer, right? This particular supply chain concept was there for a long time. And I mean, several companies have evaluated these supply chains and then optimized to reduce any of the bottlenecks and then keep on improving it. So this is the definition of the supply chain. But just to set the expectation correct, this integrated supply chain for API does not mean digitizing the existing supply chains, right? Obviously, there is an effort going on digitizing the conventional supply chain, but we are not going to talk about that today. This integrated supply chain for API means take how you would produce an API, a new end-to-end digital system to enable the business model around API. So how would you produce an API? How will you take it to the customers for them to consume? So why specific about API? So what we believe is APIs are the products of the 21st century, right? And that is the reason why we are going into these particular topics today and tomorrow on how you would produce API by using the supply chain. So why? So this is the definition of a product. I mean, the product means different stuff to different people, and often what comes to our mind is the physical product. But if you look at the definition too, especially like something such as service that is marketed or sold as a commodity, again, it is considered as a product, and which is the close definition which we are going to discuss today, right? So if you look at the evolution of the product, again, just think about the physical product or in the automobile industry. It started with the horse carriages, and then in the early stage, there were the early stage car, which is the second picture. And then in the 80s, you had some improvement to that particular model. And then now you have Teslas and other vehicles which are more modern and more advanced. So there is a transition going from kind of a mechanical to electrical to kind of electronics and computer related stuff. And if you take any of the cars today, there are lots of software components involved, and most of the controls and most of the manipulations are happening by using software, right? So there was a seminal paper written by Mark Andreessen in 2011 on defining software is eating the world. So I mean, this is a very great paper. If you haven't read it, please take a look in this particular paper. So basically what he was telling is the software will control or will have an impact on almost all the life in the world, right? Almost all the industries in the world. So if you take, for example, healthcare now, right? Take CT scanner or any other instruments. So if you go to a hospital, there are systems which manages your records and patient management and drug management and so on. Everything is driven out of software. Or if you take telecommunication, again, you are calling somebody, there is a router, switches, and so on. Everything is controlled through software. So basically, the software is controlling the world in current era, right? And then Satya and Adela went one step ahead and defined every company is a software company. Obviously, I mean, these companies might produce several products and services like car or mobile phone or any of these physical devices, but the competitive advantage comes from the use of their softwares. Obviously, I mean, the real value people are going to get from these products are going to be based on the software which is underneath and which is powering these components. So take the product experiences even now, right? In like 10, 15 years back, we used to buy these phones, which is called feature phone now. You buy with a set of features. You can use any of the features which are available at that point and nothing else. Only features available at the time of you are buying the phone, you will continue to use it. And that's it for the feature phone. But if you look at the smartphone now, right, and you buy the phone, but you keep on adding applications on top of it. And even the phone you might have bought last year, but still you can install some application which was invented or which was produced today. That means the actual experience of the phone is coming from the applications which are running on the phone, and that has changed the mindset of the phone from us, right? And obviously, I mean, the experience is coming primarily from the software components which are underneath. And take car again, right? In the case of connected car, for example, you have a physical object, it's a physical car, but then the capabilities are coming from by using several software components like accident detections or where you are in the location detections or Wi-Fi breakdown notification, etc., etc. The cool factor is like, even though the car you bought like 5 years ago, still the capability of the car is keep on improving by the softwares. The software is keep on improving either from the car side or from the backend side, and the capabilities of the car as an experience the user is having is keep on improving. And take Uber, for example, right? Uber is it's a very great software company, kind of a case study, right? In the case of Uber, I mean, you are using an application, mobile application to call a car, and you give the location where you are in, the location where you had to go, and then pay the fare, the car fee by using a credit card, and then some car comes and picks you. But if you look at Uber, the map functionality they are using is not coming from them, right? It is coming from Google, Google Maps, and so on. The payment functionality coming from some other payment provider, maybe like Stripes or some other payment provider, and they don't even own cars. But what they are building is a software experience by bringing components from various suppliers and then provide a digital experience for the users. And as far as the user is concerned, their primary concern is how I'm going to go from A to B, and that particular problem is solved by Uber by inventing on the concepts of software, right? So what is underneath everything, all these experiences are APIs, right? And that's why we claim like APIs are the 21st century product. And all these experiences coming from the API. So the APIs are like the Lego box, Lego blocks in this particular example, in this particular picture, right? So I mean, for people who are familiar with Lego and who enjoy using Lego, you will understand that Lego blocks, you can, as far as you have the creativity and as far as you have the imagination, you can build any kind of a structure by using a Lego block. The same way that like you have the APIs as the components and as the products, and then you can build any additional or any creative way of creating a digital experience for the users. Right? So if you look at any of the product architecture now, here we are discussing about two different architecture. One is the centralized and decentralized. In both of them, the API will be the central part of this particular architecture. So if you look at the centralized architecture, which is on the left-hand side, we have defined utility API, domain API, and edge APIs. Where the utility APIs will expose your data or system of records, etc., for the users. So basically, this is exposing your data and the capabilities, core technical capabilities as APIs. Then we have the domain API, which are exposing your business logics, and often these are like combined API, or by combining multiple utility APIs, you might create a domain API together with some logic, business logic, and then that exposed as a API. And then the edge APIs fit between the end user application and your API management layer. So basically, these are the APIs, a managed API you will expose to your end users, for your application developers to use to build some digital experiences for the end users, right? So the core fact is this is a layered or segmented architecture, but still what brings them together as a single architecture is this glue part, which is done by the APIs, right? And if you look at the current, I mean, distributed or in a cloud native modern architecture, still, I mean, all these services and all these APIs are distributed, and each of these components, still they expose API, and API are the way all of these components are connected together to build the overall experience. Again, even in this particular case, you can have the utility API, domain API, and edge API based on the data they are exposing, or based on the way the APIs are used. But still, these are like distributed and glued together by using the API. So API sits at the core part of any of the current architecture. If you take any architecture now, right, any of the product architecture. So we have written these two reference architecture in this particular link we have given. This is released under Creative Commons, and we encourage people to take a look as well as give feedback around about these concepts. So this feedback can be, I mean, you can create an issue by giving your comments, or you can provide pull request, or can even give comments about whether you like it or whether you agree with this particular architecture, and so on. So let's take a look at the history of this API, right? I mean, these are history of the applications. So if you look at like 70s, you had mainframe and you have a monolithic applications, right? So basically this monolithic application solves a particular problem. It might be solving the problem well enough. However, when there are changes happening in the market or changes happening in the environment, it's very hard to change this application. It's like changing, turning a ship, very hard. You have to make sure that it doesn't break any of the existing systems. And the moment you touch in one part, the entire application is affected, and possibly without you realizing and understanding, it might change the behavior of the applications. So the business leaders and technical leaders understood this particular problem, and they started to disaggregate the applications. But initially it meant as enterprise applications, split it into multiple parts, and then departmental applications split it further into the parts, and so on and so on. And then we came to these APIs and microservices and serverless architecture and splitting these particular components. So what happened here is when we split each of these parts so that we can change the agility of the organization, we can change the behavior of the application, behavior of the organizations based on the changing demands in the market. We splitted the APIs and then combined them together to form an applications, right? So that is how the APIs initially created. Initially, it was meant as an, even though it's meant as an internal API, you identified that the APIs went to a sufficiently isolated and useful functionality. This is useful for even outside the organization people, right? Outside other third-party providers and other third-party partners. So what happened at that stage is the organization started selling these API, right? So obviously, then we started treating this as a product, and there are several monetization models people have identified or come up with to sell this particular API. So these are like 4 different buckets of monetization which we were discussing. So the first one is the direct monetized, where the organization expose the API for their consumers. Here, the consumers can be their partners or other third-party application builders, etc. They are using the API provided by the organization, and then they are paying for the usage of the API. So basically what happens is the organization exposes and then manages the API and then monetize the API directly, right? And in the second case, the APIs are indirectly monetized, where the APIs are
Hi, Shankar. Seems to be, I'm not sure if it's a issue with our connection. We can see you now, Shankar. You're on mute, though.
okay. Can you hear me?
Yes, yes.
Okay. So I mean, this combined physical is the connected car is an example of that, where you pay for the car and then possibly pay for the monthly or annual service charges. And then the API providers will get some revenue share from the car sale or etc. So similarly, I mean, any physical products you are selling on the
Hi,
mobile phone.
Shankar. Quick one. Your screen is not visible.
Oh, okay. Sorry about that.
No problem.
Can you see?
Perfect. Yes.
Okay, cool. And the fourth model is kind of a backbone for digital transformation. So the organizations, they expose their capabilities and data and their system of records into APIs so that any application builders can come and consume the API. So in the model here, this is kind of a common model where the API provider or the backbone provides an application building capabilities as well as exposing the APIs so that any application builders can come and consume the API. They can just subscribe and consume the API without worrying about how the internal plumbings and internal data structures are working, etc. But they care is the user experience and what the end user wants, and they see a catalog of capabilities available. They just combine the capability based on their imagination and based on their creativity, and then build an application and give it to their end users. So these are like four different models where people can make money out of these API products. So we now established why API as a product, why we are considering API as a product, and now let's look at the supply chain. So this is a great paper, a great article written in the New Stack, which is comparing the industry supply chain with the digital supply chain. So, I mean, if you look at any of the physical products, obviously you have to start with some source material, whether it can be components, ingredients, or any other sources which you are getting, then combining them and manufacture a product. And then when the product is available, you need to distribute to various distributors so that they can take the product to the customers. They sell the products, and then the end users, so the customers, consume the product to get the benefit out of the product, right? If you look at the API lifecycle, API experience, again, there is a similar experience, right? So initially, you will understand the discovery part, where you understand what are the data and system of records or services you want to expose, which are available as ingredients or components. Then you develop some digital solutions by combining these APIs, or possibly you might create a new API out of combining other APIs or other data sources. You deploy the API or applications on some place so that the end users can come and consume. Then the customers will come and register for the API or the product, and then they will use it and they will get an experience. So basically, you have a close, similar supply chain going in the case of API products as well. And then these products don't exist alone, right? And these products exist in and rely on ecosystem. So, I mean, if you look at any of the current products, the consumer expectation is so complex that a single company might not be able to build all the capabilities needed to build a product, right? So they have to rely on an ecosystem to get supplies around. So even, I mean, when we talk about Uber example, they are taking some API from Google Maps, some API from payment providers, and etc., and then put together to build a new digital experience, right? So these products exist in an ecosystem. So that raises a requirement for a marketplace. So this is a typical picture of a Sunday market, for example, right? So in a market, take an example of a market, the Sunday market. In a market, there are several providers bringing several items like vegetables, fruits, fish, or whatnot. But there might be some other people who are playing music, some other people having kind of drawing some pictures and so on. And there are lots of consumers coming to consume various items. So what the marketplace provides the consumer is all the capabilities or all the items in a single place, right? So maybe like take an example. I am going to the market to buy a vegetable, right? My expectation was to buy a vegetable. So I go to the market, but I happen to notice there's a drawing about a dog, and I want to hang it in my room. So I haven't planned to buy a drawing, but I went and noticed there is a drawing available, and then I purchased. My primary expectation was to buy vegetables, but because the marketplace bringing various products, various other kinds of products, I also noticed and bought that particular product. So basically, I mean, when we go to Amazon, again, as an example, we buy a particular book and then we identify several other kind of items. When it say people buy this, they also bought this, and you're tempted to buy those items as well. So marketplace accelerates or synergize the efforts from various vendors, right? So often the common question people ask is, I have a API portal, isn't that a marketplace? So the API portal is a single provider. It is like you are having a drawing shop, right? So let's say if you are having a drawing shop, you are selling drawings. The only people you will sell drawings are people who are planned and coming to buy a drawing from your shop, right? Not a random person who is going to buy a vegetable and happen to notice that you have a drawing and coming and buying you a drawing. That's the difference between a particular focused shop versus a marketplace. Marketplace, there are multiple providers, and the multiple providers attract multiple consumers, and that multiple consumers attracts more providers, and then it will come into a synergy and an ecosystem, and it will build organically into a bigger ecosystem, right? So with we have identified 5 different kinds of marketplaces, especially in the case of APIs. The first one is the internal federated marketplace. So this is an internal consumption, but still there are independent parties building APIs. It can be like business units, or it can be self-isolated teams who are building these APIs. So for a application builder, for them to understand what are the capabilities available, instead of going to each of these business units and identifying the API, they can come to a common place and can discover all the capabilities or all the APIs available at that point to build the applications. That is a common internal usage in the case of marketplace. So the second pattern is partner marketplace, where the primary API provider runs the marketplace, but they let their partners also to publish the APIs. So the advantage here is consumer comes and they identify the primary API provider. At the same time, the value additions are coming from the partner network as well, and then they can consume all the API from a single place, which eases their life and gives a good experience for them. Third model is a closed group marketplace. So due to some reasons, if you want only a closed set of people to consume your API, then this is an example of providing a closed group marketplace. For example, take an example of a digital government, right? And each of these government departments or government organizations, they want to expose the API, but the government might not want some random developer to come and build an application. So they want somebody who are certified, somebody who understand the complete knowledge of the departments to build the applications. So in this particular case, I mean, this might be like invite only participants, or possibly there might be a registration process, but the registration might go under an approval process where the API providers or the marketplace vendor will evaluate the consumers and then approve only selected people based on some criteria. So the fourth model is similar to the second model, where the primary provider as well as partners expose their API similar to the partner marketplace, but the revenue share will be a bit different in this particular case. So any revenue coming might be shared between these API providers, or there might be some complex logic behind how they want to share the revenues between the participants. So again, the revenue sharing models might be different in this particular marketplace. The fifth model is aggregator marketplace, where some API provider, the marketplace provider, combine APIs from multiple API provider, the individual API providers, combine them together into a single value-added API, and then expose that combined API as in the marketplace for others to consume. So basically, they are providing some value addition. So these are the 5 models we have identified up to now, and I mean, can explain any of the current marketplace needs by using these 5 patterns. So let's go back to the integrated supply chain of the physical products, so conventional integrated supply chain, and this supply chain has several components or capabilities. Let's start from the product lifecycle management, where you have to design, research, design, develop, sell the product, and end of life the product, etc. So the entire product lifecycle has to be there. And then supply chain management, evaluating the supply chain, improve the performance, etc. will be there. And then logistic management, bringing the sources, and then providing the distributor channels and so on, and how you manage them together will be there. And then ERP and financials to evaluate the commercial and technical success of the products will be there. So these are kind of components needed in the conventional product integrated supply chain. So what we can learn for the API integrated supply chain in this particular case, right? So we have an API product management, which is equivalent to the product lifecycle management, where we manage the life cycle of the API, starting from cradle to grave. Then you have the API insights and monetization, which is similar to ERP and financial, to evaluate the technical and commercial success of the API. You have the API integrations and enablement to create a new API, which is similar to supply chain management. Then you have the API DevOps and management to deploy the API in an automatic way, which is similar to the logistics. So putting them together, this particular picture will be the components or the capabilities of an integrated supply chain for the APIs, right? But if you take a deeper look, each of these needs a lot of capabilities. So for an organization needs an integrated supply chain, needs an entire set of capabilities listed in this particular picture, all right? So in the case of API integration, for example, you might have some legacy applications, or you might have some industry applications which are talking on a particular protocol, or you might have several data, event and stream stream processing engines, etc. So you need some way of creating APIs by combining all of these items, and there has to be capabilities available in order to do that. And from an API product management point of view, you had to worry about how to onboard the users, how to manage their single sign-on, how to manage their subscriptions, and then if they had to discover the documentation to build applications and to understand the capabilities of the API, provide an API marketplace for others to come and discover the APIs available, etc., right? And then as part of the API DevOps and management, you had to worry about the CI/CD pipeline so that you can manage the API automatically. And then you might want to deploy the APIs on a high available, on a continuously available manner, so that you want to worry about multi-cloud deployments, hybrid deployments, Kubernetes, or blue-green canary deployment patterns, so that you can provide continuous operations of the API and then seamless upgrades to newer versions and so on. Then in order to evaluate the success of the API, you might use monitoring, billing, analytics, tracing, reporting, and whatnot. So basically, for an organization to build all this capability, they had to look for a vendor who provides all these capabilities and not a single part only. Or possibly they can get different parts from different vendors and put together to create the supply chain. But for a success of the API product, for the success of the API economy, basically you need all these capabilities in your supply chain so that you can manage the supply chain effectively. And this is our API market vision. So we took the analogy as quantum duality. So basically wave versus particle nature of the quantum. Similarly, the API has a business side as well as the technology side. So some people take the extreme of business or extreme of technology, but what will happen is if you take the extreme of business, you might design a good business API, but technically it might not work or not perform or not scale very well, and it's be a failure. Or if you take a very good technology API, still it can provide lots of technology values, but as a business capability, it might not be a not so business viable API. So basically, you need to have a equal or sufficient amount of each side for the success of the API. And then these are like four different aspects you need to look for the API, starting from the federation and business model. How are you going to sell the APIs? How do you want to make money? We looked at different monetization models. Then there are heterogeneous API landscape by involving multiple parties. Then people are moving to cloud, so you need to worry about the multi-cloud, hybrid deployment, etc. And then how the business models when the APIs are available in cloud or power some cloud business and so on. And then modernizing, there is a modernization going on. People are using Microsoft gateways, service meshes, and so on. You need to enable automatic management of the API or seamless API development experience. And then there are several languages, polyglot languages and technologies available. So you might want to worry about all of that language or heterogeneous nature of the technology. And you want to expose more than just a REST or open API specification by using GraphQL, gRPC, Kafka, etc. Right? So basically, for the success of the API, you need to worry about each of these, and each of these has a technology as well as the business angle, and you need to look on those angles for the success of the API. And then there is a huge shift happening to the cloud native nature of the application. So we talk about the application disaggregation, right? I talk about going from a monolithic applications to API by splitting the applications into various parts. So similar trend, similar disruption happen on the infrastructure as well. Like for example, if you have Like we have monolithic running on a mainframe. Now you have API. Still, the API has to run on a mainframe. That is not going to work, right? So the infrastructure also went on a similar transition, starting from mainframe to commodity physical servers to virtual servers to containers to etc. So there is a transition happening on that side, so that each of these infrastructure is going on a very lightweight and cloud native way into containers and Kubernetes. Then when you have all these APIs available, typically, I mean, in a conventional way, people combine them as a centralized center of excellence like ESBs and so on. But now it is more of a decentralized integrations happening with isolated teams or self managing teams, and they run by using API-led decentralized integrations. In the conventional way, APIs are only available for internal users and partners only, but now APIs are everywhere. Anybody can come and consume the APIs. API gateways are also going on a diet. Basically, it's no longer centralized API. Often you have different APIs, OH gateway or micro gateway, powering a single API, and all of these are like distributed and so on. And even payment model is like you pay at the front versus you pay as you go and so on. So basically, the transition is happening from cloud native as well. And then if you look at the functionality, so basically API federation, you need to, if you look at the marketplace, the APIs are provided by multiple vendors. So often the API marketplace has to work with multiple gateways, right? So basically you might have a single control plane, but it has to manage multiple gateways. So it has to consume API from multiple gateways. So we are working on a specification called the API Federation specifications, which you can access from this particular link, and please come and participate and contribute to this as well. So basically, this allows you to unify the analytics, policy enforcement, subscription, billing, etc., on various gateways from the marketplace itself, so that you can have a single marketplace, and then the APIs can be powered by multiple different kinds of gateways. So you can combine multiple vendors in order to provide a diversified ecosystem for you to have an API strategy. And these are some statistics we put to show the business impact of the API. Obviously, I mean, APIs are becoming more and more important for the business. So this particular first report, this Akamai report, came on 2019, I believe, which says 83% of the web traffic now is coming from API. Right, not the HTML or not the web pages, but rather API traffic is the majority traffic in the internet. And the second report was McKinsey's in 2017, which says like 1 trillion revenue is up for grab through the APIs. Again, this is keep on improving, increasing, and there are lots of revenues available as part of the API business. And if you take third report is on, if you take a typical business, 25% of their revenue is coming from API now, but the trend is like it is keep on increasing, right? So obviously, I mean, at this stage, we need to worry about the APIs for a commercial success of the organization. So let's switch gears and talk a bit about building this integrated API supply chain on how to implement, as well as from a strategy point of view. So from WSO2, we offer these products as in order to facilitate the implementation of the API supply chain. So we have API Manager, which can manage API. Basically, it's provide full lifecycle API management capability. Then we have the enterprise integrator, which allows you to integrate any systems, data sources, and legacy applications and other systems to provide APIs. Then we have the identity server, which provides single sign-on, identity federation, authentication, authorization, all security aspects of the API lifecycles. Then we have two verticals, business vertical applications as well, combined by using the APIs. One is the open banking for the PSD2 and other open banking specifications. And then we are also working on these healthcare integrations. So these are the products and solutions we use or we provide to facilitate the API lifecycle, API integrated cycle. So this is a full platform. So we talk about what are the capabilities needed in order to get the integrated supply chain. So basically, this particular picture shows what components are coming from these products, which will fit into the integrated supply chain, which provides capabilities. And you can run this particular platform on top of any of the infrastructure available at the bottom. So basically, it can be run on any kinds of infrastructure. And from a strategy point of view, we offer some consultancy services as well. This is something called WSO2 Impulse service. It's a strategic high-level service, which Asanka, you will meet Asanka in a bit, Asanka heading this particular effort. So basically, we go to customers and work with the customer to improve the people, process, and technology on top of culture and architecture, for them to have a digital alignment and digitally transform the organization so that they have a proper digital strategy, long-term digital strategy for their organization. And as a specialized consultancy, we also have the API strategy consultancy, where we go and work with the customer, work with the team to define the strategy, then how to align the people, then bring all the technology alignment to build the APIs, build necessary capabilities needed to have the proper API lifecycle, as well as proper API supply chain, and then even to engage, evangelize with other marketplace providers and even with the API, and then iteratively improve over the period the entire experience of the API lifecycle, etc. So these are two kind of a strategic consultancy we do, and please reach out to us if you need more details. So, I mean, these are some of the links you can reach out to us. The last three is how you can reach out to me. Please reach out if you have any questions, and thank you very much for attending the WSO2 Summit. I can take some questions, I guess. Yeah, some more minutes.
Thanks a lot, Shank. We had a few questions, and I think the team has already taken them.
Okay.
So I think we should be able to move to our next session. Thanks a lot, Shank.
Thank you. Okay.
All right, so let's move on to our next session. How has APIs accelerated the journey at Telecom Malaysia? So to talk about this, we have our next keynote. I'm very excited to have him at WSO2 Summit APAC. He's the CIO of Telecom Malaysia, and there he's responsible for the overall formulation of the IT and digital services strategy at Telecom Malaysia. And he's also the chairman of Telecom Research and Development, whole subsidiary of Telecom Malaysia as well. We're very glad to have him at our APAC Summit. Like I said before, please welcome CIO of Telecom Malaysia, M. Umapati Sivan. Over to you, Umapati.
Hi there, guys. Thanks for the invitation, and I'm really, it's a pleasure for us to be part of this event. I would like to first start off by saying, you know, the idea of, you know, for us to talk about APIs in many streams. I'm going to just quickly start sharing my my presentation, and then we can take this forward. Okay, just to give you a background about us, we in Telecom Malaysia, we are the largest provider of fixed line, what do you call it, services, mainly on the broadband side of business. We are also a convergence provider, a service provider in Malaysia, where we also have the content and also the mobility service. And we are also the largest provider for the SME and enterprise market. So our base of the service has always been about providing connectivity, and but now we are moving to the space of solution providing as well. Most of this has to do with building the over-the-top capabilities that is required for the upcoming what do you call that requirements, and also the current requirements. The current requirements, of course, due to the the pandemic that we have seen all across the world, the same what do you call it issues has happened here in Malaysia. A lot of people are now have moved from working from office to working from anywhere, especially from working from home. And due to that, our demand has increased. But our clients and our partners have come back to us and asked us to also look at what are the things that that we can provide to value add to the base service of connectivity excellence. So with that, I would like to just quickly go through the presentation material, which has to do with how API will become the accelerator for the telco business moving forward. So the first thing that I would like to share with you guys is the challenges that has been there for the CSP providers or the telcos, as we have mentioned. The environment that the telcos has been number one, we have a very heterogeneous environment from systems to processes and also resources, mainly due to the fact that we're moving away from a traditional telco providing to a more digitalized telco providing. So our focus in the IT and digital organization of TM Malaysia is to simplify the processes, standardize the system, and have a stable resources to provide a lean, mean, and clean setup for the organization. This is basically looking at the various issues that also not Telecom Malaysia has. This is an issue that actually exists in most of the telcos and even in other industries, because even bankings, thing like what Shankar was just saying before, they have been in the predominantly in the traditional infrastructure, which is in this case a mainframe systems. But what they have done now is they have actually mixed it up with the mainframe still being there with new set of systems. So the heterogeneous systems are always there. Because of the heterogeneous system, the process are very, very complex, because you got to manage both the digital and non-digital setup. Then finally, you also have the different kind of resource management, from skills to capabilities, and hence we're trying to simplify the whole process by making sure that the systems are standard and ensuring that we have a good setup of the resources to manage this thing. This is how we're going to drive the lean, mean, and clean setup. So what do we aspire? So from what I've just mentioned earlier, we are trying to move the value chain of the enablers, in this case, the technology providers, both in IT and also in network, and also the other digital streams, to become a digital telco. This is our drive that has been there in TM for the last 3-4 years, and we would like to become a digital telco, and we're heading towards there by 2021. By next year, we believe with some marquee projects that we have, we believe that we can drive a more of a digital ecosystem within our organization. But the ultimate goal is to move away from a digital telco to becoming a cognitive telco. So what is cognitive telco? It's basically having the capability to have hyper personalization, more persona management, and the whole intelligence to be able to do real time service providing. And that's going to be important. It's becoming the if you talk about global, is becoming the Amazons of the what you call of the telco providing. Or locally, we can even talk about Lazadas and what have you. So this goal of the becoming a cognitive telco is something that we are driving in our organization, and it's going to become a main catalyst going forward. Now, so we know what to become. So the most important points on having this thing is making sure that we have a platform that we can work on. So I'm glad to share the collaboration with WSO2 has actually been for the last 3 to 4 years, in which we started off by our research and development team of TM adopting the WSO2 as a platform to become a brokerage or a what do you call that, an enabler for our internal usage. From there, we actually started building a lot of the applications and the services that can be actually shared to the external market as well. Just to scale back on this, if you look at the diagram that we have shown, what we actually use the WSO2 platform is first to become a data and service hosting platform. So that's how we start. So from there, we actually scale this up to be able to create the microservices. And microservices, we believe, are going to be the future on how we actually reduce the dependency on on having multiple applications and service providing. We can actually build the capabilities on our own, and from there we can actually move up to be able to create the service exchange platform that helps to bring in different service providers to plug in their data points, so we can actually have a consolidated digital service. This in Telecom Malaysia, we call this the Open Innovation Platform, and this is how we have actually been driving it, in the last 3 to 4 years, and we believe this is going to be the future of how we're going to do business moving forward. I just want to check with the what do you call that, with the team, if we have if I'm too fast or going too fast. If not, then I'm going to just take up some questions in the meantime. Okay, I guess I can just move forward. So the evolution that we are looking at in the path of this API, from the looks of it, we actually have what do you call that, three evolution path. The first one is actually the ability to have an agile capability, both combining the delivery mechanism of agile and waterfall, and also looking at it from a more of a reactive kind of capability. And this is where the APIs are just a component of of sharing. So it's actually being able to share data between different side of technologies. Then it's moving it into a platform orchestration. When it comes to the orchestration level, this is where we actually enrich the APIs from becoming a single layer of sharing into multi-layer. So it's more transactional, and this is where we start building the microservices. And from there, we actually move it into what we call a intelligent, what do you call that, platform. This intelligent platform is where we believe that we will move away from DevOps to NoOps, in which most of the things can be actually done without the needing of people, to eyeball, to even do code development. It can be lifted off, and it can actually managed by itself. This, we believe, will be the right path for us to go forward. And to achieve this is where we believe that our drive and our key takeaways for the upcoming future is to make sure that as a telco, we need to move into the space of cognitive. We can't just stay on the space of digital, because everybody is a digital telco. So to really value add and take it to the next level, we need to become a cognitive telco. We want the data to be the intelligence for us to drive the insights and personalization. And we believe API is in the core for us to become a CSP business accelerator. That's all I have. If I can actually ask, invite any questions. If not, we can move to the next stage. Over to you again.
Thanks a lot, Sivan. Checking if we have any questions, but yeah, I think it was quite comprehensive. So thank you so much.
Thanks again.
Right, thank you. All right, so before we move on to the next session, we just quickly want to remind you how you can engage with our teams and do ask questions, especially if you have any follow-up questions to Sivan sessions and anything special on how Telecom Malaysia does. You can get in touch with us. You can simply send in your questions on our Q&A on Zoom, or you can join WSO2summits.slack.com, or you can simply go on our Twitter and share your experience with us. You can use hashtag WSO2 Summit, hashtag Integrated API Supply Chain, and hashtag API Supply Chain. We have a lot more interesting sessions coming up today, where we will later on we'll be talking about how APIs are the products of the 21st century. So we're looking forward to that session, which will be presented by Nuan later. Speaking of Nuan, you will be, since you're attending APAC Summit, you will be able to walk away with a copy of Microservices Security in Action. This is co-authored both by Nuan Dias, who is the VP and Deputy CTO of API Management, as well as Prabhat Srivaradhana, VP and Deputy CTO of IT and Access Management at WSO2. And it's from Manning Publications. And you will get a discount from Manning Publications, a 50% discount if you simply follow us on Twitter. So what you can do is go to Twitter and follow us, and make sure you share your experience, like I said before, with the hashtags that you see on your screen, hashtag WSO2 Summit, and keep the chatter going. We see a lot of comments and stuff coming in our chat as well, saying thank you for the presentation, and great presentation. Glad to hear this feedback. We do see a question. Sivan, if you're still online, maybe are you able to take a question that came in? If you just check the Q&A.
Yeah, there's a question from Sampat Kumar that posted the question on what kind of API integration is done by TM. So our API integration at this point in time has been done in many areas, Sampat. So the first one is actually at the level of business support system and operation support system. This is basically just to enable the capability for the likes of payment gateways and also other service providers to to integrate to us. So we don't have to have multiple payment gateway to be connected to us. We use the same API, we enrich the API, and then we use it from microservices. And it can be provided to multiple things. So it can be operator billings that comes from the likes of Google Play and Apple Store, but it can also come from the banking brokerage organizations and what have you. Hopefully that answered the question. I think there's another question on TM stands for Telecom. Yes, it stands for Telecom Malaysia. That's what TM stands for. I think that's the two questions we have now.
I think there's one more question.
There is?
Yes. Scroll a little bit, saying, what is your suggestion for an API gateway?
All right, on the question of on API gateway. So if you remember the three building blocks that I mentioned, how you start at the beginning and as you move on to the next level. The API gateway works when you are able to really enrich your API capabilities. So the gateway process can, it works especially when you are becoming a service provider within your realm. So to give you an idea, we in the telco space have a lot of data points on customer base. But we also have a lot of data points on customer behaviors, which website they went for and all those things. So when you become a API gateway, when you are able to enrich this information and provide it to the other service providers, and this can actually help them to become more, intelligent in providing the right service. So the quick answer for that is WSO2 is one of the leading, provider out there that can actually provide this service. But at the same time, there are, capabilities that you can enrich on your own as well. I guess that's about it, Shara?
Yeah, I think you covered it all. Thank you so much, Sivan.
All right, then.
Well, thank you so much. All right.
APIs are touching every facet of our digital society, as well as the underlying trends. That will ultimately generate nearly 1 billion APIs in the coming years. All digital transformation is now API-driven, and integration technologies underpin their evolution. With services and microservices being the heart of an enterprise, changing the way your company delivers connected digital experiences to your customers, partners, and employees can be hard and needs to be simplified. You achieve this through APIs and API management. Introducing WSO2 API Manager, the leading open source API management technology, the fast, affordable, and scalable path to becoming a digital-driven organization via APIs. WSO2 API Manager platform allows your business to create, secure, publish, manage, analyze, and connect your APIs, API products, and endpoints. It gives you the ability to connect your applications and data across the enterprise and across clouds. Monetization will assist API publishers to earn money by exposing their services. Also, they can define various billing plans for the same service. Not just that, with our cloud-native API Micro Gateway, you can now intercept both north-south and east-west traffic going into your microservices. It has a super easy developer workflow, which allows it to be deployed on any type of infrastructure. What's more, with our depth of technology, you can also implement advanced and customized security and access management integration, helping you with your most challenging API and integration projects. Don't just take our word for it. We've helped and partnered with many organizations across the world to transform their business through API strategies. We can help you too. Download the WSO2 API Manager today and let's help you transform your organization.
And we are back. Thank you so much for joining WSO2 Summit APAC. We've got a lot more exciting sessions coming up. And up next, we will be talking to someone from the integration team of WSO2. And we have Isru coming up, where he will be talking about microservices and how you can navigate through creating endpoints with microservices. And for that, we have Isru Udana. He is a part of the WSO2 Enterprise Integrator team, someone who has provided technical leadership to the WSO2 integration team and has worked with a lot of customers as well. And we've got him presenting our next session. Please welcome Associate Director and Architect at WSO2, Isru Udana. Over to you, Isru.
Thanks, Ishara. So let me share my screen. Okay, so let's get started. So in this session, first I will do a quick introduction to integration microservices, and then we'll discuss about challenges when it comes to building integration microservices and solutions for them. And then later on, we'll discuss about how we can build integration microservices using WSO2 technology. Okay, so before we go deep into integration microservices, let me look at what microservices really are. I'm pretty sure that most of you are already familiar with microservices, but just to give a quick recap on the definition, the microservices are a way of building software applications as a collection of independent and autonomous services. So these services we are talking here are business capability oriented, and obviously they are loosely coupled. The key motivation behind introducing this microservices architecture is basically the breaking of the monolithic. So breaking of the monolithic in the sense the elimination of the existing centralized enterprise service bus architecture. So with the elimination of ESB, it was suggested to use smart endpoints and dump pipes. So let's look at what these smart endpoints and dump pipes are. Okay, so before we move into smart endpoints and dump pipes, so let me take a step back and see the existing centralized or ESB style integration architecture. So as you can see in this picture, so we have different systems, data, applications, and services. So we need to integrate these different systems and application and data. So what we do is we bring in a component called an ESB, the enterprise service bus, into the middle and do all kind of wiring between these services and systems with the ESB. So at the ESB, you will do all kinds of integration logic. You could do transformation, routing, filtering, all kinds of integration stuff can be happen at the integration layer. So at the ESB, what you expose is a service that consumers can consume. But in modern in centralized architecture, we are not directly exposing those virtual services created at the ESB. Rather, we bringing another layer called the API management layer, where you can apply different kinds of quality of stuff aspect into the services that you have exposed over ESB. So basically, you could apply security, throttling, and also the monetization stuff can happen at the API management layer. So at the API management layer, you are exposing a managed API for your consumers. So this architecture works pretty well for most of the organizations. So even though this works well, there are some limitations. So limitations are mainly due to the centralized nature of this architecture. So it's when it comes to agility, there are if you want to introduce a new solution, how quickly you can do it, and how can you scale components individually. So there are problems related to that, and also when it comes to containers and container orchestration frameworks like Kubernetes. So these centralized architectures does not go hand in hand with those deployments as well. So because of these problems, a new architectural style got emerged. So in microservices architecture, what we have is a set of services interconnected to each other. So in here, there's no central layer that control the integration. So rather, we have set of services that is interconnected to each other. So in previous case, what we had was a centralized component. We can call it as a smart pipe. But in this case, we don't have a smart pipe. Rather, we have a smart set of smart endpoints connected through some dumb channels. So basically, these channels are called dumb pipes. These interconnection can happen directly over protocols like HTTP, and also this interconnection can happen through event brokers as well. So this event broker is just a dumb broker that does the interconnection between two different services. Okay, so having that many services, having to integrate that many services, you will be facing problems related to these connections and communication. So basically, when number of services get increased, it's somewhat hard to manage. So, so the problem here, the problem we are facing here is that, so here in this architecture, we don't have the abstractions coming from the ESB layer. So in the previous architecture, you are provided with all the abstraction at the ESB layer to make the integration much easier. But in this architecture, everything has to be done at each of these services. That's why we call them as smart endpoints. So basically, all the integration logic plus the business logic has to be happen at these endpoints. So so even though we position we position microservices architecture is a way of making stuff more easier, the integration problem equally exists in this as well. So in the centralized architecture, the integration happens at a central component. So in this architecture, that integration problem is distributed across different individual services. So this picture is taken from Uber. So basically, this is drawn from one of their tracing tools. So you could see that there are multiple services, and also there are a number of interaction between each of these services. So this is somewhat similar to the spaghetti integration pattern we used to have in pre-ESB era. So so that's why we actually have to be extra careful when it comes to designing integration microservices. Okay, so since the integration of microservices is somewhat hard, so people try to solve that problem by introducing various stuff. So introduction of service mesh is one such attempt. So in service mesh, what we have is a sidecar that sits alongside with the microservice, and we can offload some of this integration stuff into this sidecar. So things like security, client-side load balancing, resiliency stuff like circuit breaking, timeouts. So those stuff can be offloaded into this sidecar. So these sidecars are controlled through a central control plane. So there's a misconception that this service mesh is equal to a distributed ESB or not. So basically, even though we can offload some of the functionalities like security or the resiliency stuff into the sidecar, the actual service composition logic has to happen at the microservices layer. So basically, let's say you have you need to integrate with 3 different services, service A, B, and C. So if you want to call them in a sequential manner, you have to write that composition logic at the microservices level. So you can't offload that responsibility to the sidecar. So that's why the service mesh is not equal to a distributed DSP. So even though the service mesh makes stuff more easier, it also introduces some other problems too. So basically, as you can see in this diagram, so when you introduce a service mesh, so the number of instances get increased, and also all the network communication has to happen through an extra hop. Okay, so if we try to map all these concepts into a typical deployment diagram, we'll end up with something like this. So here at the bottom, we have atomic microservices. So basically it take care of all the core business logic. And next we have the integration microservices, so which basically do composition of multiple microservices. And then on top of these microservices layer, then you have the API services or the edge services layer. They are where you have the API gateways. So there can be one or multiple API gateways depending on your requirement. So the APIs exposed by the gateway layer can be consumed by the consumers. So you can integrate this architecture, this system with existing legacy systems or existing SaaS applications through the interfaces exposed by those systems. Okay, so now let's talk about building smart endpoints with integration microservices. So the first thing would be to find the right granularity. So if you have thousands of services, and unless you are a mega cloud or a large enterprise which provides number of business capabilities, having that many services gives an idea that you have followed a too fine-grained approach. So the idea is that scoping your service around a business capability. So the Uber came up with this a new model called the domain-oriented microservices architecture. So basically, they are talking about scoping the microservices for a particular domain. So they had a problem where okay, so if some in their system they used to have thousands of microservices. So if something goes wrong, to troubleshoot a problem, engineer has to work through 50 different services across 12 different teams. So that's complex and that's not that simple. So that's not what you expect from the microservices architecture. So when you find the right granularity, then you need to look for a technology that can be used to build integration microservices. So the technology that we are going to use for building integration microservices has to provide proper abstractions. So basically, if that technology can provide proper abstractions that can take care of inter-service communication, then the developers can focus on their development, their actual business logic, rather than focusing on inter-service communication. So basically, a technology that used to build microservices should provide support to well-known protocols and standards, things like HTTP, gRPC, WebSockets. And so supporting those are essential, but also it's good to have abstractions for supporting various SaaS applications, various well-known SaaS applications like Salesforce, and also proprietary systems like SAP and some of the legacy systems. So if you have abstractions for integrating directly with those systems, that made the developer life more easier. Okay, then we have the different service composition pattern. The first one is active composition, where you actively compose your integrations. So this is called service orchestration. So basically, let's say you have 3 different services, service A, B, and C. So if you want to actively composite, actively call these services, you can call the service A and get the response, call the service B, get the response. So likewise, in here, you are actively compositing, you are doing the composition logic actively. So, and the other approach is the reactive approach. So in the reactive approach, the services are listening for events. So when it receives an event, it do something based on the event and emit another event. So that's the reactive approach. And there are some other approaches and patterns like event sourcing, CQRS. So I'm not going to touch on those today. Okay, so the microservices architecture go hand in hand with containers and container orchestration frameworks. So having native support for containers, Docker, and container orchestration framework like Kubernetes is an added advantage. So when it comes to containers, so the technology that we are selecting to build integration microservices should have some key features. So the fast boot up time and low memory consumption is essential. So apart from that, so these container orchestration frameworks like Kubernetes provide SDKs and APIs that gives flexibility to natively integrate your integration technology with those systems. So say for example, the Kubernetes has the operator SDK that you can use to build Kubernetes operators. So if your integration technology provider or the technology that you are going to use to build integration microservices provide those operators, is going to be a really good advantage when it comes to dealing with the deployment. Okay, so if you are coming from an enterprise integration background, I'm pretty sure almost all of you are familiar with enterprise integration patterns. So even though these enterprise integration patterns are designed for centralized ESB style architecture, most of these patterns are equally valid for microservices as well. So stuff like forking, joining, split, aggregation. So all these are equally valid for microservices architecture as well. So the only difference is that all the EIPs or the enterprise integration patterns are implemented at the central ESB component in the centralized architecture. But in here, some of those are implemented at the microservices level or the smart endpoint, and some are implemented at the platform level at the container orchestration framework like Kubernetes. As we all know, networks are not reliable. So network is not going to be reliable forever. So when it comes to designing integration microservices, we need to take that into account. So as we discussed previously, service mesh take care of this resiliency aspect. So resiliency is stuff related to circuit breaking, retrying, timeout, bulkhead, those are taken care by the service mesh. But not all deployment has this service mesh component in their deployment. So basically, if the technology that we are going to use for building integration microservices can provide these abstraction, that's going to be an added advantage. Okay, so in microservices architecture, we are dealing with hundreds of services. So it's obvious that to integrate these hundreds of services, we have to mix and match stuff. So we have to do matching between different message formats. So we have to do transformations. We have to deal with different kind of schemas. So having a very good powerful or tools to do these kind of mapping is essential for a technology provider. So basically, it's not all about programmatically implementing these different kinds of conversions. It's good to have the visual tools that you can get the inputs and outputs and do mappings. So having powerful tools for doing complex type conversion is very important. Okay, so now let's look at how we can use WSO2 technology to build integration microservices. As we all know, WSO2 Enterprise Integrator is the product that we have in our product stack for building integration solutions. So Enterprise Integrator is an API-centric, cloud-native, and distributed integration platform that can cater for both microservices and centralized integration patterns. So both are supported. So apart from the key integration capabilities, so it has support for data integration as well as new emerging integration technologies like streaming integration. And it's highly extensible. So we have a number of integration connectors that you can plug into the core component and extend the integration capabilities. So when it comes to microservices integration, the enterprise integrator provide a unique low-code approach. So basically, you will be provided with a integrated development environment where you can use it for graphically design your integration. And also this enterprise integrator has native support for container orchestration frameworks like Kubernetes and Docker. So it gets well integrated into these ecosystems. And also fast boot up time and the low resource consumption make it ideal for the microservices architecture. So if you are familiar with WSO2 products, so we used to have a product called WSO2 Enterprise Service Bus. The Enterprise Integrator is the successor of Enterprise Service Bus product. So basically the Enterprise Integrator uses the same integration runtime we used to have in ESB, which means that this Enterprise Integrator can be deployed as an Enterprise Service Bus into any solution. So it supports almost all the enterprise integration patterns, and it supports various, almost all the well-known protocols and standards. The streaming integration is a new emerging technology. So basically, we have the enterprise integrator got a component called the streaming integrator, which is solely focused on the streaming stuff. So basically, the streaming integrator can listen for event streams coming from various event sources and act upon those events and create integrations and build solutions. So basically, we are mainly focusing on change data capture and ETL capabilities. Okay, so all these integrations we talked about can be developed using the visual tooling experience that is provided in Enterprise Integrator. So we are having a tool called the Integration Studio, which you can use to starting from design all the way up to deploying it to some deployment. You can do it through the Integration Studio. So it provides a drag and drop graphical experience where you can develop your integration configuration. And when you want to get started with the integration project immediately, so Integration Studio provides set of templates. So these templates are available for almost all the well-known patterns. So if you want to get started with your project very quickly, you can select one of these templates and get started. So as I mentioned earlier, having powerful data transformation capabilities is very important when it comes to designing integration microservices. So the Integration Studio provides a visual experience when it comes to doing different data transformation. So here in this picture, you could see that the data mapper tool we have to do mapping between two different messages. So, and also this tool provides support for evaluate your mapping in real time. Okay, so when it comes to testing and debugging, so similar to how we debug code, the programs you've written in any language using an integrated development environment, this enterprise integration studio provide a way to debug and test your integrations while you are developing. So you could put the breakpoints for different configuration elements that is available in Integration Studio. and then you could debug the flow while you are developing your configuration. And also for testing, also it has built-in capabilities, built-in clients, and all the stuff are integrated into this studio. Okay, so when it comes to integration flows testing, so the integration studio has a test framework. So basically you could write unit test cases for each and every configuration that you develop. So, and also that can be integrated to your CI/CD flow as well. Okay, so the connectors. So basically, as I mentioned previously, the WSO2 store has over 250 connectors to connect with all the well-known SaaS applications and most of the proprietary systems. And also you could write your own connector. So this is the way that you could extend the functionality of the integration runtime. Okay, so that's all I need to talk about the enterprise integrator. So I'm pretty sure by now almost everybody is heard of Ballerina. So Ballerina is a programming language that we have been working on. So it provides a unique way of building smart endpoints and pipes. So you can see there will be a lot of improvements coming in the Ballerina area in near future. Okay, so that's all what I plan to talk today. So we can take questions if you have.
Yes, we actually have a couple of questions that came in, including good feedback for the presentation as well. So if you just look at the Q&A, there are some questions you can take.
Okay, so we have a question asking, does WS2 integration support EDI integration with AS2 SFTP protocol for communication? So the SFTP is supported. For AS2, we have a connector. So that's not that matured, but still support is there. So we have been working on that, working on improving that as well. Okay, can we create custom drag and drop component and can we customize API MEI? If yes, please share the documentation. Okay, so I guess what meant by the question is whether we can create, we can introduce new drag and drop components. So basically the mediators into the integration studio. So what we recommend is to use, if you want to introduce some extensibility to the existing integration framework, there are set of extension points in each of the layer that is provided in the integration component. So basically, one such extension point is the mediator. So so mediators, so mainly, so we used to have a custom mediator that you could plug into the main runtime as well as the studio, but we no longer recommended that. Now what we recommend is to use a connector. So you could develop your connector and import that connector into the integration runtime. So, and as well as to the integration studio. So when you import that connector into the integration studio, you could drag and drop stuff from the palette into the main editor that you develop integration. So that is possible, and we have the documentation, we will share that.
Yeah, I think that covers all the questions, Isuru. Thank you so much.
Okay.
APIs are touching every facet of our digital society, as well as the underlying trends. That will ultimately generate nearly 1 billion APIs in the coming years. All digital transformation is now API-driven, and integration technologies underpin their evolution. With services and microservices being the heart of an enterprise, changing the way your company delivers connected digital experiences to your customers, partners, and employees can be hard and needs to be simplified. You achieve this through APIs and API management. Introducing WSO2 API Manager, the leading open source API management technology, the fast, affordable, and scalable path to becoming a digital-driven organization via APIs. WSO2 API Manager platform allows your business to create, secure, publish, manage, analyze, and connect your APIs, API products, and endpoints. It gives you the ability to connect your applications and data across the enterprise and across clouds. Monetization will assist API publishers to earn money by exposing their services. Also, they can define various billing plans for the same service. Not just that, with our cloud-native API Micro Gateway, you can now intercept both north-south and east-west traffic going into your microservices. It has a super easy developer workflow, which allows it to be deployed on any type of infrastructure. What's more, with our depth of technology, you can also implement advanced and customized security and access management integration, helping you with your most challenging API and integration projects. Don't just take our word for it. We've helped and partnered with many organizations across the world to transform their business through API strategies. We can help you too. Download the WSO2 API Manager today and let's help you transform your organization.
That's a quick overview of WSO2 API Manager. And speaking of APIs, how can APIs enable digital transformation and ecosystem collaboration? We will be talking about how this has happened at OCBC in Singapore. So to take us through their experience and their success story, I'm really excited to introduce you to our next speaker of WSO2 Summit APAC. Everyone, please welcome VP of API and SOA Microservices Delivery Lead at OCBC Singapore, Akash Saxena. Over to you, Akash.
Yeah, thanks, Yashara. Hello. Yes, is everyone able to hear me?
Yes, we can hear you loud and clear.
Okay, let me just share my screen. Thanks, Ishara. Hi, this is Akash. So I work in OCBC Bank in Singapore. I'm going to talk about the brief digital transformation journey that we took from last few years and how APIs have helped us transforming the bank to a more advanced stage where we expose our assets to our partners. So the brief agenda that I would like to cover here is first of all, I'll brief about what OCBC is because some of you may not know. What is our API? I'll talk about our API catalog, which is available to the public. I'll briefly mention about the strategy that we are going to adopt within OCBC with respect to the APIs. What is the tech stack we have? What is the architecture we have? And what are the capabilities that we're going to offer? Lastly, I would also like to talk about our transformation journey, with respect to APIs, which we started a few years back, and the potential use cases and the business opportunities that we got once we embarked on this API journey. With respect to OCBC, OCBC is one of the largest banks here in Singapore. We have a quite significant presence in Malaysia, Indonesia, and Greater China. Recently, a few years back, we even acquired OCBC Vinhang Bank, which is now a part of our OCBC larger group. We also have a private lending firm bank called Bank of Singapore, which is also a part of OCBC group. So overall, we have around 610 branches globally, and we have a total employee strength of around 29,000 globally. Okay, so I think the session is about API. So I'll just brief what exactly API means to us. So as the diagram depicts, right, how, okay, earlier our assets or our services within the bank were confined in the boundaries of our own systems. The outside people, third parties were not able to share them properly. We were not able to expose them properly. And that's where we decided, okay, we have to embark a journey on the API so that all our assets gets automatically transformed to an API, and we expose them in a very secured manner to our third party developers, to our customers, which in turn will benefit the end users. So that was the objective in mind when we started this API journey. And I think more or less it covers how the API ecosystem will help not only our partners, our app developers, but their own end users also. Okay, thanks. Next, I would like to talk about our API portal, which we have in public domain. You can visit the website. It's api.ocbc.com. Okay, we brand it as Connect to OCBC. Now, okay, this portal, we were the first bank to launch this portal way back in 2016 in the Southeast Asia market. And of course, with the help of WSO2, we used their products and we were able to accomplish this in a very short span of time. Over the last few years, these are the 5 pillars that we have thought about in our API journey that we want to enrich with respect to our API catalog. Some of the broader functions is, one way is, okay, yes, we want to publish more APIs to our customers. That is our top goal, so that we have an increased collaboration with them. Second, what we want is, once you use our API, we want to productionize it in a very faster and lean way. We do not want to spend so much time once it is ready to be used, and immediately we want to productionize it. So what are we doing about it? Second thing is, the portal has to be self-service portal. So what I mean by self-service is, okay, we do not want to have so many interventions, and we want to automate the process as much as we can with respect to onboarding of our customers, with respect to onboarding of our app developers. The fourth aspect that we want to achieve is MVP. Of course, everyone wants it faster to the market. And then the last aspect is about our extended outreach. So the portal serves all these purposes with respect to our app developers, with respect to our third parties, with respect to the companies who want to do business with OCBC, not in terms of money, but in terms of investing with us in our own API journey. So several of these tasks we are currently doing in our bank, where we are going to upgrade our portal and we are going to have rich features added for the public to use. So I would suggest, like, whenever you guys have time, you can go and visit this api.ocbc.com. Okay, the catalog. So because we are a financial institution, so currently we offer close to 400 plus APIs on our public portal, where we have across each of the APIs we have categorized into different domains. And you could see here, like, we have wide category of domain APIs which we have offering to the public. It could be related to accounts, it could be related to cards, it could be related to payments, insurance products, customer services, corporate services, consumer service. It could be even like simplistic APIs could be related to FX, Forex rates, reward points with regard cards, etc., etc. And we are still growing. So how do we decide, okay, which particular bank service we expose as an API to public? So internally, we do an assessment, we do a study, and whatever we as a group within the bank decides, okay, this particular service, it can be used for the public, it can be used for our third party, it can help the public. That's where we take a decision and we put the API for the public domain in our portal, which is connect to ocbc.com. Oh, that was more about our portal. Next, I would like to talk something about our strategy, which is depicted in this triangle. So, okay, when we started our journey, our foundation was laid. So what do I mean by the foundation is, okay, we had an API store, we had gateway products, we had reporting, we had some sort of API analytics and APIs published. So that was the very base foundation which we laid, okay, with the help of WSO2 products. Later, then we expanded it. What do you mean by expansion is, okay, we went from the OCBC group within Singapore, we went ahead to other markets within where our bank operates, which is Malaysia, Greater China, Hong Kong, etc. We made our gateway capabilities and API capabilities robust enough so that we expanded our infra. But that with that foundation, we then entered the market. Now, what you see in the green layer is something that we are embarking our journey on. So what do you mean by that? Think of it like what we did is once the foundation is built, what are the next steps? What is the next evolution that we want to reach? So these are some of the aspects that we are trying about. We are trying to containerize all our we are trying to containerize all our RESTful services. We are going to think about micro gateways implementations. Of course, when we talk of containers, it comes with CI/CD pipelines, which will help reduce the time for deployment. We are moving from RESTful APIs to event-based API model, where we help our async subscribers. Okay, we are also targeting how to build a robust API pricing model so that we can offer better models for pricing for our customers. We are also targeting towards security enhancements. Okay, what is new in the security industry? For example, we started with basic OAuth or two-way SSL. We moved to SAML authentication. From there, we moved to JWT authentication, likewise, and so forth. So what is latest in the industry and what most of our partners choose to communicate with respect to security? We try to offer new capabilities with respect to security and other features. So once we have these capabilities bundled with us, along with our basic foundation, what is our next goal is how do we onboard our partners fast? And how do we embark a journey so that the onboarding becomes hassle-free for a new customer who wants to use our API? Along with that, we as a bank, we also want to adhere to all our regulatory compliances and standards and achieve some certification there. So what we envision with all these pillars is we want to have all our business assets that can be exposed. It can be leveraged by a third party in a secured way. So we want to make API as a business model. So that is our target goal here. And with that strategy, we are building all these features so that we make a true case of API as a business model and as a service we provide to all our partners. Okay, next, I would like to talk something about what this slide depicts is the OCBC API model, where we talk of different layers we have categorized. So one of the thing is, okay, how do we manage the operations of our API? How do we manage the lifecycle governance of the API? How is the viability of API team and API model will look like? How is the service operations being managed, the security aspects, and then the bottom one is the most important one, where we talk about how do we accelerate the pace of delivery, how do we adhere to all the architectural guidelines. At the same time, okay, we as a bank, we have our core banking systems, and like every other organization, we have a lot of products which are legacy. Okay, and how do we use those legacy backend systems and we enable APIs out of them? So we have to do some sort of investment and some sort of study to understand those legacy systems and expose them as a service, which later can be transformed as an API. So okay, like a typical API gateway architecture, I would like to talk about. So what you see in blue was our existing architecture. We've had all our banking channels using our banking services, which were like web services, SOA services, or microservices, which used to connect to our internal banking applications. Now, how the APIs have helped us, how these API products have helped us is, which is the brown layer, which tells, okay, all our external developers, all who wants to innovate and do some planning, our mobile applications, our monetization and IoT devices, they all connect via our gateway, and there, which embarks a journey to use all our banking applications from our bank. So this is where we have enabled API traffic that comes to our bank via third parties and via any other external provider. The next thing, okay, this one is, okay, what API means to us is not just a RESTful API where we offer a service to our partner, but the whole ecosystem around it. So when I say an ecosystem around it, it means all these capabilities that we would like to have with our enhancements. So one of the, okay, let's start with the sandbox. Okay, so sandbox is something which is an API portal which allows all our public to have a face to the OCBC API where they can log into our API portal. They can test our API, they can play around with it. And if they really want to use it, we will assess them further so that they can start using the APIs in our test and production environments. So this is a very important thing, a role which Sandbox plays. The next thing is, okay, of course, we want to enable more and more APIs. Whatever we build, we want it to be API enabled so that our catalog of APIs grows continuously. And that's where we use ESBs of WSO2, which their team has talked about earlier, and we are using the same product to help in that. Second thing is the insightful APIs. Now, what do I mean by insightful? So once we have an API, right, we must have knowledge about who is using, how much he is using, what pattern he is using for, so that we get an analytics view out of it. So we are also building analytics capability with our API ecosystem so that we have a dashboard and we know who is using what, how much he is using, so that we can optimize it further. The second aspect is, okay, with respect to the security enhancements that we have given to all our customers is, okay, we offer JWT support, we offer OpenID, SAML, we even offer LDAP as well as OAuth 2.0 communication with respect to any security. So we cover a wide range of security aspects with to all our partners and community. The next aspects we even cover with respect to security is some sort of message scanning. Okay, so this is specifically useful where we scan a message. If let's say if there is a high value payment or if there is a use case for having a bulk payments, we do message scanning feature, which is available with us. We also have tokenization features where we mask a typical thing where we mask the sensitive data and we tokenize it so that it is more safe for our customers to use our APIs. We are also working on bulk API streaming data capabilities that we offer for our APIs. As I mentioned earlier, even the event-based APIs with respect to Kafka and other features we are offering to our partners. Next comes the containers and the microservices. So all our RESTful implementations with respect to the backend integration, with respect to the core banking services and offerings, we are trying to containerize them using the container platforms, and so that we offer more robustness to our service, we offer less outages, and the service is available 24/7 and the service can scale on demand. So those are the features that we are trying to offer to all our partners. With respect to logging, with respect to other optimizations, we use standard Kibana-based logging and other features. Of course, we try to offer a consolidated view of logging. So at one spot, we know for each of our APIs where the logs are located, and so that troubleshooting for operations team is easy. Likewise, we strengthen our infra. We are using our private cloud so that on-demand scaling can be on or off on basis of need. So the infra is also strengthened. We are looking for expansions, and we have already expanded from Singapore region, moving out to Malaysia, moving out to Hong Kong, China, and other regions where our bank operates. So these are some of the capabilities that OCBC is doing with respect to API ecosystem in general. Next thing is, okay, some of the optimizations that we are doing with respect to APIs, I would like to talk about capacity upgrade. So we have extended our hardware capacities. We are scaling horizontally as well as verticals. We are able to manage automated software upgrades. Now, again, all this is possible because we have adopted containerized approach, and we are using CI/CD even for software upgrades. Our logging is very much standardized. We have policy controls in place. Second thing, which I mentioned earlier also, we are trying to adopt to industry-based solution with some new capabilities like gRPC and GraphQL on support. We are trying to give an API gateway. Uh, we also have the capability to throttle each of our API, where we control how much requests a partner can send based on whatever demand it is. And of course, all our APIs are now RESTful and they are containerized with respect to our products that we are using for WSO2. Second, okay, I would also like to take you about our transformation journey, where what we started off. So in 2014, Smart Nation Singapore government, so there was a drive from the Singapore government and MAS, which is a regulatory body of Singapore, to start digital innovations, specifically with respect to APIs and how we expose our assets to third party. So likewise, in May 2016, we were the first bank in Southeast Asia to launch the API developer portal, which we branded as Connect to OCBC. I've briefed it about it in my start of my session. Okay, in 2017, we had our very first partnership with one of the government bodies in Singapore, and it was our first partner. Likewise, in the same thing, we took part in Singapore FinTech, where we advise our community, we advise our Singapore University colleagues and other graduates, okay, about APIs. We conduct hackathons and likewise and so forth. Likewise, in 2019 OCBC, we had published close to 200 plus APIs in our portal, and we won the Asian Banker Award for the best API initiative with respect to the payments. Moving fast forward to 2020, okay, we have already expanded regionally to different countries where we operate, and we are available in Singapore, Malaysia, China, and Hong Kong. Likewise, we continue our journey, where we call our journey as a 2.0, where more and more partners, we are trying to onboard them. So we have a wide range of partners across industry, across domains, who are our API, who are using our APIs and our very deemed partners with us and collaborating with us on all aspects. Next, okay, I would like to talk about the business opportunities that API has given us in terms of how the bank sees the market, or likewise how the market sees the bank. So one of the key things it does is, okay, it drives innovation and improve branding. So what do we mean by innovation is, okay, we are liaising with a lot of startups and fintechs who use our products. And earlier it was not at all possible because all this was confined within the bank. All our services were available within the banking systems, but they were not available to any third-party organizations or fintechs. So that has improved by adopting our API journey. Second thing is the brand recognition that our bank carries with respect to APIs. So we were, as I mentioned earlier, we were the first to launch the OCBC API portal, and we were the first to reach in Singapore market with respect to open APIs. The second aspect is, okay, how OCBC products and services we offer through our partner apps. So we have increased more and more touch points, and these third-party apps can connect via different modes of way, via different security aspects to us, and you use our services. Second thing is, okay, what the outreach of our services with respect to APIs to our partners and customers has helped us to monetize also some of the products that we offer today. So this would not have been possible if we would not have embarked on an API journey, and we would have remained confined with respect to our services and systems available within. So with this help with APIs, it has increased our presence within the market. It has increased our branding to all our competitors. It has increased our ecosystem and our reach to all our third parties, all the partners who are going to work with us. Okay, this is my last slide. So here, this is our portal. It just gives a snapshot of our portal. I would like everyone to visit it. So this is our group portal where we are trying to onboard all our subsidiaries, and all our APIs and catalogs is available here. It's api.ocbc.com. So that's all about the API vision and how the digital transformation is taking place in our bank. So with this, I think with this, what you have understood is some of the high level things that we are doing in the bank, which are going to drive digital innovations. And API is the key epitome and the key centric point around it through which the entire ecosystem we are trying to build.
Thanks a lot.
Is there any
Akash.
question? Is there any question? Yeah. Okay.
Yeah, we actually have a list of questions. If you just check the Q&A, and I really like seeing the slide of how, the WSO2 platform is actually, working with OCBC, giving all these results you spoke about. If you just move to the Q&A box, you'd see some of the questions that we've got for you.
Just a sec. Okay, how many registered? Okay, I mean, I cannot share the number, how many registered external developers we have, but definitely it's in thousands, I can tell you. And it is across the globe because the portal is being used everywhere and it's accessible to everyone. So we have a lot of third-party developers who are working with us. There are a lot. Okay, I think the next question is for the bulk file upload and download. Okay, okay, this one actually, I think Sampath Kumar. Okay, so Sampath. Okay, so here, right? What we envision is not with respect to bulk file downloads and uploads. Basically, we are not talking of host-to-host integration here, but what we envision as a bulk API is where I get a request. Basically, it could be a request in any of the ISO formats with respect to, let's say I get a request in one ISO format for 1,000 payments and I execute it one by one. And we offer this capability where you can do an inquiry for your job. We can do an inquiry for a specific API. So it's not about the download and upload of the API we are talking of, but how do we handle the traffic, the bulk traffic in one shot? So we are talking of that. So the product, of course, if you just talk of the file upload and the download, the product uses mostly we are using Control M, Connect Direct, the traditional ones. But if you talk of the APIs, how we handle the bulk APIs, the product we are using today the API manager, WSO2 API manager. How is the insights achieved? Okay, so I think the next question, I'll take this. Insights is achieved whatever passes through our API gateway layer, whether it's one API or dozens of API, whether it's through one partner or different partner, everything we log it in a centralized place. On top of that centralized place, we have an analytics engine, which has a dashboard. So that is where we can measure the metrics of the API. And it's when I say metrics, it's not just, I mean that, okay, what is the quantity, what is the volume of this API by this partner or by this customer, what is the usage? Not just that, we would also drill down to the payloads and to the data level where we know, okay, this specific customer is using our API and he's using for very high value transactions. Or another customer who is using the same API, but the volume is high, but per transaction, the dollar amount is low. And all these patterns, we have it. And likewise, we can change the pricing of our APIs if need be. So that's where analytics helps us based on the usage, based on these trends. We try to identify what people actually want, what the specific customers actually need. Okay, authorization of OCBC APIs for different partners or customers. Auth and auth. I think this auth and OCBC API for different partners. Okay, there's one more question for Sampath. I'm not sure it's for WSO2 or it's for me, but we can answer. So we have like for authentication or authorization at our APIs, we have different levels of security frameworks available. It could include your JWT, OAuth, SAML authentication. It could include a standard authentication with respect to two-way SSL. For some of the partners, it may also include IP whitelisting and IP filtering. So likewise and so forth. So the access token validity changes for different partners based on how we assess the threat and assessment. So that's where, so we have the flexibility to provide different forms of security to different partners based on their profile assessment that is done with us. I think Ishara, that is all, I think. Is there any other question that?
I do see a couple more questions.
Okay, putting.
There's one on service orchestration.
Okay.
I think that will be taken.
Yeah. So there's one question. Okay, Siddharth has asked. Okay, putting all the bank's data public can be a challenging task in the aspect. What are the basic steps you follow to secure your APIs? Okay. So okay, first and foremost, okay, we as a bank, of course, we offer our APIs for all the public use, but not everyone can productionize with us. So we have a lot of screening process that we take into consideration if we want to onboard a company to our API ecosystem. So there's a lot of screening process involved, which includes the AML checks also. Second, with respect to the system integration, if the third party does with us, as I mentioned earlier, we have all the checks in place, which could include, we have a DDoS protector, we have IP whitelisting, we have digital signing available, we have two-way SSL available, we have SAML tokens, OAuth tokens, JWT, and all sorts of flavors available with respect to security. So we ensure that the data is not breached, and the data is only seen what we want. Is only basically it's selected per partner, the access is given. So authorization is in place where only a specific API with respect to specific usage you can see. We also have the capability to per customer, we can have the capability. When I say customer, to me, it's a third party. So we have a capability where we decide, okay, for this customer, these specific fields we can give or we not give, even though he's using the same API. So that sort of capability is available along with all the necessary controls. That's where we control our API, its usage, and the data of the bank.
Cool. I think that covers. I feel like there's probably there are a few more questions coming in. Maybe we can take one more, Akash.
Okay, I'll take the NDI one. So I think, okay, NDI one, we are partnering with the government to work on this NDI initiative, but it is a bit of journey that we have taken. But however, I can tell you with respect to the open banking marketplace, we are almost there. And I think you would hear from the Singapore government very soon within this year, where lots of bank, including OCBC, will be productionizing with respect to open banking. Now, what it means is you as a customer from another bank can view the data of another banks, whoever is collaborated. So think of it like an OCBC bank customer can view his bank accounts of other banks within the OCBC portal. So there's something which we are working with the government and we are trying to come up with the design, and it's almost on the final stages and it will be productionized soon.
Okay, I think there are a couple more questions coming in, Akash, but what I'm going to do is I'll probably send them your way so you can take them after your session. Thank you so much. And thank you for being a part of WSO2 Summit, Akash. We really liked your talk. Thank you.
Thank you. Thank you.
And thanks to everyone who's been sending their questions as well. You can continue to do that. If you're joining us via Zoom, you can not use the chat option because your question might get buried with everyone else's, the buzz and the conversation that's going on. So you can send your questions on the chat option and our speakers will take it, or we can just take it live during the sessions as well. But if you have any other questions about how WSO2 products exactly work, like, Akash just took you through OCBC's case study, you can join our Oxygen Bar on the WSO2 Summit Slack channel. That is w2summit.slack.com. And do share your experience on Twitter. We love, seeing your feedback as well. And make sure you use the hashtags, hashtag WSO2 Summit, hashtag Integrated API Supply Chain, and hashtag API Supply Chain. Speaking of APIs, our next session is about, how APIs are the product of the 21st century. And to take you through this session, I'd like to invite our next speaker. He is the product lead of WSO2 API Manager, and he's the Vice President and Deputy CTO of API Management and Integration at WSO2. Everyone, please welcome Nuan Dias. Over to you, Nuan.
Thanks a lot, Ishara. I hope my audio is good.
It's good.
All right, great. Let me share my screen real quick. Okay, thanks everyone for joining in. And thanks again, Ishara, for the intro. So I'll be talking you through why I think APIs are the products of the 21st century, and basically why I think you as a business should be doing APIs, or rather considering APIs and products. What are the benefits that you will get out of it, and how you can think of your APIs as products. What are the things that you need to do as an organization and technically in order to achieve this milestone of treating your APIs as products. So to begin with, I'd like to talk about what a product is. So I'm sure everyone has an opinion on this, an idea on this. So it's basically anything that is used to satisfy the desire of a customer, the desire or a need of a customer, of a consumer. That's basically what a product is, right? So it can be offered for free. It can be offered it can be offered commercially. Nevertheless, a product is something that solves a particular problem for you, for a particular consumer of the product. So if you think of Google search, that is basically a very simple example of a product. Simple in the sense in what it does, not how it does it. So Google search is basically a product that I'm sure all of us have used or are using at the moment as well. And it's offered to us as free. But that's really what we think. It's not really free if you really think about it. So we don't really use our credit card to do a Google search, which is true. But we do actually pay Google with all of our data by letting Google know our search preferences, our interests, and things like that. So all of this data is used by Google for various other reasons, for placing ads strategically and for giving you various kinds of results and based on what you search for. So that's basically one example of a very simple product. So, and I'm sure all of you who are joining are in some kind of a business, and you provide your business value to your customers. Now, the richness of your business value actually lies in whatever the data that you have about your customers and the processes or the services that you run on top of that data. That's basically where all of your wealth lies in. So if you think of Google, if you think of Google search, the wealth of Google search is basically in its data. So Google search's data is basically an index of the whole World Wide Web, right? So they have stored all of these indexes in their data centers, and they run very complicated processes, algorithms, and the analysis on this data. That basically is what is considered as the wealth of Google search. And we consume Google search in various forms. Like we use various kinds of applications, various kinds of devices to consume Google search. So for example, the address bar on our web browser is now a client to the Google search API. The Google search web page, google.com, is basically an application to Google search, and we have the Google search mobile application and so on, right? So users consume the value of your business or the richness of your business through some form of an application. And all of this is powered by some kind of an API. So while it is true that users would consume some form of an application to get the value of your business, those applications become the device or the medium of them consuming that value, and APIs become the delivery mechanism of that value. It's basically APIs that take the richness of your business and provide it to various kinds of applications. That's basically what the Google Search API is all about. There are numerous consumers of it, and all of this has been made possible by the Google Search API that is basically acting as a medium of transporting this value or delivering this value to its consumers. So if you look at the application market, which is where users consume these values mostly. So the two most popular application markets out there in the world has been there for about just over a decade now, and you can see the increase in applications or the number of applications they've added. And this is all because this application market is giving value to the user. It's making the user's life easier, efficient, or cheaper or faster in some way. So the Play Store has close to about 3 million apps. This was in Q1 this year, and the Apple App Store has about 2.2 million apps. So all of these apps are basically adding value, and that's why we see a significant growth of not just the number of apps, but also the revenue that it has brought in. So this year, the mobile application revenue is expected to grow to about $200 billion, right? So that speaks the value these applications give to the users. And thinking about value, you should perceive value slightly differently. So value is something that makes your customer better in some way, something more delightful, something more delicious, right? So a customer uses a particular product. It could be an application of some sort, right? A customer uses a particular product to get the value out of it. And this is really where our sales should be focused on, right? Our value should actually be focused on not just the product that we are trying to sell, but on what it makes the customer at the end of the day, what the customer becomes at the end of the day. So value is basically a combination of your customer's assets or problems that he has, and the product that is being added on top of it to make the customer something better than he or she actually was in the beginning. So this is actually the value that we are talking about, and value is basically what we should be selling to our customers. And how do you get this value out, right? How do you think of this value? How do you perceive this value? So I think when you are building this value proposition of your organization, which could be in the banking industry, in insurance, in retail, it doesn't really matter. So to build your value proposition, I think there are 4 main areas that you should be focusing on. First is to pick the proper customer, right? You should have pick the correct customer and understand what the issues that they're going through, like what are the problems they are having, what are the inefficiencies they are having, how can you make their life cheaper or more efficient. And you should understand what they want to get to as well. Where does your customer want to get to? What are their goals and so on? And know the business assets that you have so that you can use them to help that customer, right? So if you understand these four things, you can easily build your value proposition. So that's basically the first step of treating your APIs as products, realizing what the value proposition of your business is, of your organization is. And then APIs become the interface for delivering this value proposition to your customers. So APIs are basically building the entire digital platform or digital experience that we are talking about, right? So think about a scenario where you'd want to, you want to find a date, right? And so you can basically use the Facebook APIs and find your friends or friends of friends who are of the right gender that you're looking for, of the right age group that you're looking for, living in the same city as you are, and so on, right? And then so using that, you can find potential matches, and then you can use Yelp's APIs basically to find a restaurant that looks good enough, right? That's close, that has good ratings, and so on. And you can use Yelp's APIs to make a reservation. And then to pick a date, you can basically use Google Calendar APIs, right? And you can basically build an application like this that uses these different APIs behind the scenes and give you that digital experience. And there are actually applications that are doing the same thing or something very similar using these kinds of APIs behind the scenes. So all of this digital experience that we are experiencing ourselves through different forms of applications are all powered by different types of APIs like this. And the integration of these different APIs creates endless possibilities for us as a business and as an ecosystem as well. So APIs become that interface of delivering that value proposition of your organization. And I think APIs do two really valuable things. One is that it connects your customers to your data and services, which is basically where your richness lies in. And it does that in a really simple way, right? So if you have heard about Plaid is a company that took a lot of legacy banking services of different banks and offered them as simple and easily consumable APIs, like modern APIs, right? So that was basically what they did, and they become an incredibly valuable company because of this, because that enabled various financial applications to integrate with different kinds of banking systems. And this simple hard work of Plaid that did the simplification process of taking banking services and APIs and exposing them as simple APIs out into the market made them an extremely valuable company. Just that, and they were bought out for about $5 billion by Visa some time ago, right? So that's basically what APIs can enable for you as a business. And we've been talking about value and figuring out what your customers really want and where they want to get you and how you can help them. But also APIs are also useful for making future business ideas and thoughts a possibility. So I'm sure some of you have heard about the what we call the Bezos mandate, which is like a mandate brought in by Amazon's CEO Jeff Bezos. So sometime back he set a mandate at Amazon saying every service in Amazon needs to be exposed as an API, and there are no exemptions to this rule. Everything has to be exposed as an API. Now, a long time since then, now if you think of the services that Amazon is offering in the form of different kinds of applications and services, I'm pretty sure Bezos did not envision all these things that Amazon is providing today, right? So, but what made those things possible is that mandate which said every service that Amazon is offering has to be exposed as an API. And once that is exposed as an API, as you grow as a business and as you start gathering ideas, as the market changes, you see lots of new opportunities coming in, and you get ideas of what new things you could do, what new products you can build, what new services you can give, and so on. And to make those things a possibility, APIs become the medium of making those things a possibility. So that APIs are not just useful for giving the value that you can pursue today as a business, but it also sets the foundation for coming up with creative business ideas and executing them in the future, and doing it pretty fast as well, right? So to make all of this possible, what you as an organization, as a company that has data and services and it's dealing with dealing with problems in a certain business vertical, need to convert your self-organization into what we call as an API native company, right? So to do this, you need to establish what we call an API product factory within your organization. Basically, a mechanism of taking your APIs from business services and converting them into API products. So these have to be treated as products if we are to generate this value that we are talking of with APIs. So this basically involves first of all manufacturing your API, meaning building your API. So use various programming languages, various protocols, various kinds of integrations between systems to build or implement your API. And then comes the assembly part. So you as a business would have multiple different kinds of services in different places. So creating an API is simply not an act of taking this service and exposing it as is. It's a matter of assembling them in such a way that it makes sense for a certain application to consume it. So then comes the assembly part and the packaging of it. So packaging basically is a matter of documenting it, like making sure you attach the relevant business plans to it, making sure you categorize it in the proper way for the proper audience and so on, and delivering it. So once you've done the packaging, it's a matter of delivering this API to your consumers. So for this, you need to figure out where your consumers are going to be and where they will be in the future as well. And based on that, you decide where your API delivery platforms are going to be. Is it going to be on the cloud? Is it going to be on-prem? Is it going to be advertised in your own marketplace, in third-party marketplaces, and all of that? And finally, all of these things need to be done in an automated fashion. So you're not going to be very efficient if you think of doing all of this as a manual process. It's like highly prone to error and all of that. So you need to bring in automation, basically mechanisms of taking a technical API and going through an automated process of converting it into a business product fully in a fully automated fashion. So this process that we are talking about, everything from assembly, packaging, and delivery, needs to be automated. So you as an organization need to think about how you can get to this stage and how you can establish this thing called the API product factory. So the WSO2 platform can help you get there with the components that it has. So we have like most of you must be knowing about the API management platform, which has like three main components to it, which we call the management plane, data plane, and the control plane. The management plane basically is the developer platforms and the business analytics. So this is where API developers would come in and design the interfaces for the API, where application developers would come in and consume the APIs, read the documentation, subscribe to APIs, and so on. And then you have the business insights, which tell you how your APIs are doing, whether they are meeting your business KPIs, and so on. The data plane is basically about the delivery mechanism of the API. So this is where the various flavors of API gateways come into the picture. So you have the server mode gateway, which we call as a regular gateway, and we have a lightweight fast micro gateway, and various integrations to Kubernetes and service meshes and so on. So this is where the delivery platform of the API is, and this is where all of your consumers, the end users, would be coming in through their devices. And we also have what we call the control plane, which is all about governance. So the control plane takes control of your APIs, like who it is being exposed to, who these APIs are being visible to, and who can access these APIs and at what rate, and all of those information. And it also checks for abnormalities and things like that. So that's basically about the API exposure layer. And then we have the integration platform, which basically helps you to do the implementation as well as the assembly of the APIs. So integration becomes a very critically important piece in your architecture, because as I said before, exposing APIs is not just a simple act of taking a service and exposing it as is. It's also a matter of integrating different pieces together to build a delightful custom experience for the consumers of the API. And identity and access management, of course, becomes important for the security aspects of it, like to bring in single sign-on into your applications, to do things like identity federation. So if you want to enable like social media login for the applications that you're building, this becomes important. This becomes important piece in your architecture to address all forms and flavors of security aspects in your platform. So this platform as a whole can be used to build what I explained earlier as the API factory. So now I hope you understand, like, APIs and API products are kind of two different things, in the sense that API products have a much more business sense and a business value to it. So if APIs are becoming your organization's products, then what you also have is a new customer base. So you will have your regular customers who are like, who could be like your insurance firms customers, your banks customers, and so on. But with APIs becoming your products, you also have a new customer base who are developers, right? So you need to cater to these developers so that they can build delightful experiences for your actual customers of the business. So if developers are your customers, then you have to think about how can you make your APIs better, and how can you serve this new customer base better now. So one of the first most important things in making your APIs interesting to your developers is to make it discoverable. So this is where what we call an API user portal, or a API store as we used to call it, comes into the picture. So you need to figure out how you can make your APIs as discoverable to the developers as possible. So there are various features like tagging, categorizing, and various flavors of search that you should enable so that your APIs become discoverable to developers. And what you see on the right is basically a portal of the New Zealand government industry, where they have used categorized APIs by ministry. So that's basically a very simple example of how you can categorize APIs and make them more discoverable to the interested audiences. And a very key important factor is to make your APIs easy to use. So this is all about making your APIs as intuitive as possible, like making it simple so that you really don't have to read a documentation to understand it, at least most part of it, right? So you should think about giving a sandbox environment for developers to try out. And of course, documentation. So documentation becomes important. Technical documentation, of course, we all understand why it's important, but business documentation is also important. So this business documentation can help make the case for the business or the management side of the developers who are going to consume this API. So your API should also speak business language, in the sense it should try to sell itself by saying that it will either earn additional revenue for your organization, it will either make your processes more efficient, it will cut down your operational costs, and so on. So that having that business documentation makes it very important, so that your developers can make a case for their management to consume and build applications on this. And you also need to think about automating the API development lifecycle. So this is basically a picture of the API automation lifecycle we have in place with the WSO2 API manager at the moment. So this is also very important. Basically, your developers really don't like to go through the aspects of business documentation and all of that, right? So this is where an API product manager role comes into play. So you should build processes in such a way where the people can do what they like doing, and you can get the desired product at the end of the day as well. So basically, this is talking about a scenario where an API developer can basically write the code, test it out, and once it's working fine, commit it to a repository and be done with their job, right? And this will take the API into a different stage where the API product manager can come in and associate the relevant business plans, and then associate whatever the business documentation and so on, and do his job. So another key aspect of a good API is that it is safe to use. So you have to think about security very critically. So usually ease of use and security don't go hand in hand. What we've seen a lot is that the more secure your systems are, the more hard it is to use, and it's for obvious reasons. But it doesn't necessarily have to be that way. So there are new protocols that you can enable on your APIs that not only make it more safer, but also make it more convenient to use. Things like biometric based authentication, right? So they are quite safer than password based systems, and it's more easier to use as well, right? So there are new protocols and new features that are available to make your APIs safer. And one mistake that I've seen many organizations do when it comes to API security is that most of them stop thinking about security at the point of authentication and authorization, right? So, but API security goes a lot more deeper than that, right? There are attacks being done on APIs through malicious payloads, through DOS attacks, and a lot of these similar kind of attacks. So authentication and authorization probably gets you halfway, like 50%, but there are a lot more things that you need to think about when thinking about end-to-end API security. And one of those being that you have to monitor the system to look for abnormalities as well, because just because like there are no authentication failures and so on doesn't mean that your system is that everything is fine. There can be intruders in the system who are using stolen credentials and so on. And when most of us are, I'm sure, are thinking about going into cloud native architectures and so on, and one of the most critically important aspects here is to make your APIs scale to demand. So if you set up systems or cloud architectures in a traditional way, basically, when I say traditional way, what we used to do in the past is to identify what our peak load is going to be in our system and then do capacity planning to cater that peak load plus a bit more, right? But if you're thinking of cloud native systems, this is going to be very expensive because you're going to be running the system at a scale that you're rarely going to need, which means you're wasting a lot of money. So that is why it's important to have an elastic system where your system scales up when there's a demand for higher, when there's a high demand, and then scales down when the demand goes down. So this is where it's important that you build what we call as an elastic data plane. So the data plane is basically the layer that takes all of your business transactions. So this data plane has to be elastic in the sense that it can scale up and scale down, and not just that, it can even scale across cloud providers and on-prem systems if required. So that's basically how you solve that particular problem. It's also important that you have a product management lifecycle to improve your APIs. So improving these APIs is a lot about monitoring them both for business KPIs as well as for operational KPIs. So business KPIs are basically things like, does this API meet my revenue goals and things like that. Operational KPIs are things like uptime, error, and so on. Now, a few minutes ago, I mentioned that developers are also now going to be your customers, which means that developer NPS or Net Promoter Score is going to be critically important as well. So you need to get feedback from developers about how your API is performing, what additional features they would like, and build a system or processes that can treat your developers as customers and give them what they are looking for. And then, of course, after you set up all this monitoring, you have to use capabilities like lifecycle management and versioning of APIs to basically improve or basically iterate on your API. And finally, think about what the business model of your API is going to be, right? So there is, when it comes to business models, there are implicit and explicit forms of monetization. So if you think of the Google Search API, that's a implicit form of monetization for Google Search. Basically, they don't charge you directly, but they charge you indirectly by selling you stuff and so on. But there are explicit monetization examples as well. So if you think of companies like Stripe or Twilio and so on, they explicitly charge you for using your API. So this could also be one monetization strategy for your APIs, and there are various forms of monetization that you can think about in the explicit world and the implicit world as well. And your API may not be like, at all earning revenue in any way, either implicitly or explicitly, right? Your API could even be an API that is used to cut down your operational costs for your organization. So think of a self-care application for your organization, right? So that kind of an application can basically cut down the number of calls that you're getting to your call center, right? Which means you can reduce the operational costs of your call center, right? So that can also be a business model for your API product. So that basically brings me to the conclusion of my session. And to conclude, I'd like to make two announcements. That is, like, this is probably something you've already heard about. So Forrester recently concluded the analysis on API management solution, and we are proud to be positioned as a leader here with 4 other vendors. So you can download the link when you receive the slides from the link below. And also, we just released WSO2 API Manager version 3.2. So these are the key features that we released with this version. So it's on the website now. And the documentation has also been updated to reflect the latest features and so on. So we are launching this today. We just launched it actually just before the summit. So you can now go ahead and use the latest version of it as well. So thank you so much for joining in. I hope the session was useful and has been interesting to all of you. There are questions, I can take them now.
Yes, there are a couple of questions. I think if you just scroll a little bit, there's a question from towards the end.
Yeah, so there's a question from Sampath Kumar, anything on open banking APIs? So yeah, we do have a product for open banking as well. So you can find it on the website that uses the WSO2 API manager and some features of the WSO2 identity server as well. So yeah, we use our platform for basically building an open banking solution. So you can go to the website and find details of it. And there's a question of how do you ensure end-to-end non-repudiation of originating use authorization to protect data identity from privileged position attacks from within the API network? Yeah, so this is from Radomir. So this is about how do you ensure end-to-end non-repudiation of originating use authorization data. So yeah, there are various mechanisms. So one is obviously to use encryption or HTTPS, basically to make sure your data is encrypted on the network. And then you use data encryption as well. So on top of HTTPS, you can encrypt the payload that goes inside as well, so that only the intended recipient can read it. And also, we don't directly propagate user credentials or user tokens to the backend from the point of the API gateway. So usually what happens is a user would send a token to the gateway, and the gateway would do the validation. And after this validation is done, user context is created with the relevant claims that are needed by the backend system. So this is done in the form of a JWT, and it is signed. And this is basically the data that is passed on into upstream services. So we don't directly propagate the tokens or any other credentials beyond the point of the API gateway as well. So there's a question on the WSO2 identity server, which is when is OAuth 2 token exchange supported? I think it already is, but probably someone we can take this, we have to confirm this later. This is about when is the IS going to support OAuth 2 token exchange. It is supported, I think. I've seen it in some form. There's a question on does OCBC use open banking API? Well, I'm not 100% sure. I do know that they use the API management platform, but I'm not sure whether the open banking is used directly. There's a question on can we integrate CMS into the WSO2 API manager? Yes, in some form. So we've done a bit of research. So there are we've done some integration with Gatsby and so on. So yes, there is some level of integration possible. Sampath is asking whether OAuth 2 is supported. Yes, OAuth 2, all of the standard grant types in the OAuth 2 specification are supported. What, according to you, are some use cases? So there's a question from Manoj asking what are some good use cases for Ballerina. So Ballerina is a programming language, and it is designed because the programming languages that are in existence today were not invented in a cloud native era. They were done earlier. So that is basically one reason why we have to, like when we are implementing microservice architectures, that is basically one reason why we have to use additional components in our microservice architecture, such as service mesh, sidecars, and so on, to basically implement this system properly. So we either need to use additional libraries or sidecar proxies to basically make our systems scalable and robust, basically. So Ballerina was invented with that mindset. What that means is basically when you're implementing a microservice in Ballerina, all of these things that you usually need to bring in other components for are built into the Ballerina programming language itself. So everything from things like observability, resiliency, and all of that is built in. So you don't really have a big need to bring in additional libraries or components to build your microservice architecture. Is token exchange also supported by API products? Yeah, so actually it's not directly related, because token exchange has no relationship to APIs or API products. It's basically tokens are basically associated to what we call service providers. So yeah, token exchange is supported for anything as well. All right. Do you officially support Docker images? Yes, you can find the official Docker images on the website, and you can basically use the Docker images. It is supported officially. Since API, there's a question from Mohit asking, since API acts as a filter at the edge, can one implement centralized logging as a filter along with filters like rate limiting authorization? Yes, definitely. So we do have some customers who are doing this. So you can, there are some built-in logging already. So you can either use that, or you could basically, if you want custom logging, you can build it as a handler and use it just like any other handler, or filter as you call it here as well.
Well, I think you tackled most of the questions and a variety of questions also, Noel. So thank you for taking them on and for your presentation today. The comments in excellent presentation. So agreed, and thank you.
Thank you. Bye.
All right. So I hope you enjoyed Nuwan's presentation, and remember that you get a copy of the book co-authored by Nuwan, which is Microservices Security in Action, all thanks to Manning Publications. Speaking of, if you follow us on Twitter, you get 50% off from Manning Publications as well. And do share your experience of WSO2 Summit via these hashtags, hashtag WSO2 Summit, hashtag Integrated API Supply Chain, and hashtag API Supply Chain. All right, we're moving on to our next session. So to present that, I'd love to invite Asanka. So if you, Asanka is bringing about 20 years of experience into the table, and we at WSO2 itself, he's worn so many hats. At a certain point, directing and owning solutions architecture, speaking to so many of our customers, including Fortune 500, and he also played the role of deputy CTO. And now he's making sure that the good news of how WSO2 technology can help your companies is spread across the world in his role as chief technology evangelist as well. And today he will be talking about what exactly a cell-based architecture is and how that approach would work in terms of APIs. So we're very excited to have him present at WSO2 Summit APAC. Everyone, please welcome Asanka Abesingha. Over to you, Asanka.
Thanks, Ishi. Hope my audio is clear.
It's clear.
Okay, let me share my screen. Can you see my screen?
I see your screen.
Okay. Okay, welcome everyone to WSO2 Summit and specifically to my session. So as Ishi mentioned, this session is about the cell-based architecture, which I authored in summer 2018 and went through many iterations. And in, I think, the fourth iteration, I released so how this will connect to the topic here, because we were talking about APIs, API supply chain, and how you can utilize APIs on your application development. So this can use as an architecture pattern to achieve your objectives. So during next 20 to 30 minutes, what I'm planning to do, explain why we created a new pattern, as well as how we created this pattern, as well as what it is. So basically, why, and like you might be wondering as well, why we need a new architecture pattern, because the microservices architecture is well established in today's modern technology, between modern technology folks, as well as the layered architecture used many years, and then cloud native architecture coming into the picture. But by considering all these existing architecture patterns, as well as the market need, we thought of introduce something new. So the motivation behind this, we identify there's a mismatch between the existing architecture patterns and what exactly architects are looking at. So the first reason for this, most of the existing architecture patterns are centralized and layered. So there's an issue with that because when you have this layered architecture and controlled by a centralized team, the layers are creating gates, and gates are blocking the flow. And if you are into more agile based development, the layered architecture doesn't fully support it, and it kind of ignore the basic agile principles, so you will be not get the full benefits out of the agile methodologies. Give me a second, there's a pop-up came in, I need to close it. Okay, sorry about that. Okay. Yeah, so that was the first motivation we had. And the second motivation, like if you look at and talk to many architects, they draw nice architecture diagrams, and those architecture diagrams are well aligned and using modern technologies and looks like what you see in the picture. But if you dig in deep and try to understand what exactly the enterprise architecture looks like, it looks like this, because it is not that clean as we expected in the previous slide. So the reason behind this, we have a lot of data systems, subsystems we purchased and built during last 2 decades, and still we need those data and systems to do day-to-day business. So we can't like completely build a greenfield system by ignoring this data that we collected for decades. So so that's the reality of the enterprise, and we need to address that. So then basically what I want to highlight here, the most of the enterprises, they have both sides, like the brownfield and greenfield. And in reality, the brownfield is more than the greenfield. So we need to address both these two spectrums. But existing architecture patterns are mainly focusing on either brownfield or greenfield. So we thought of we have to address both sides of this particular problem. And then when we did this research, we identified the reference architectures available online are not reference architectures per se. Those are reference implementations. Why I claim it like that, the reference architectures available either focusing on a specific technology or the it is focusing on how you build a system using a specific vendor-based technology. So those are biased to a specific vendor or a specific technology. So we thought of when building the reference architecture, it has to be completely technology neutral as well as vendor neutral. Then the next motivation we had, the current architecture patterns are not supporting to bring new technologies once you build the application systems using the particular architecture pattern and move it to production systems. But as an architect or a technology enthusiastic, you would like to bring new technologies into the system and improve the functionality, performance, and the flexibility of the system, but it doesn't support. So we thought of the architecture pattern should have that flexibility for you to bring new technologies without affecting the current systems. Like while you are business as usual, you should be able to update the systems without any issue. Then the next motivation was like there's a gap in between the architecture development and deployment, or between the architect, developer, and the DevOps engineer, because there's no common language or common thing that you can take it from the architecture phase into the development and then deploy into your infrastructure. So we thought of address this as well, and there should be something that you can architect and then develop based on that particular architecture and deploy as it is without changing the design you did. Then the microservices and latest decentralized architecture approaches bringing a lot of complexity. And I think you have seen this diagram. It's a very popular diagram about Uber microservices architecture. So there are a lot of moving parts in this. And when you have the decentralization and then a lot of microservices, it looks like this. And you need some dependency management while you are giving more and more flexibility for your developers to build these independent services in your infrastructure. So those were the motivation factors that we had. So before jumping to the particular architecture pattern, let's look at a little bit of the history and how these architecture patterns evolved during last 2 decades. So the architecture started with monolith applications that the entire the user interfaces, business logic, and data bundled together. And with the advancement of the data technologies, the 2T architecture came into the picture and moved the user interfaces and business logic from the data layer. And then the 3T architecture, the most interesting era, came after that, around 90s, that the user interfaces, business logic, data are moving to 3 layers. And there were sub patterns came with that, like model view controller, model view controller 2, then enhance it with the service oriented architecture by wrapping the business logic with services and APIs. And there were sub patterns of service oriented architecture, like event driven architecture, web oriented architecture, and it moved into more microservices based architecture patterns in modern world. So what I want to highlight here, it started with the layered architectures and then move into more segmented based approach. So this is an architecture diagram that I introduced around 2012. It is a layered architecture, but little different from a traditional layered architecture. It's a 2-dimensional view, not like a single dimensional stack that you will see in most of the layered architecture diagrams. We introduced the functional capabilities as well as the life cycle of an application into the same diagram to cover an end-to-end life cycle of an API. And then we use system of systems concepts while building this. And it was a very useful diagram those days, even the architects heavily using this pattern in modern world as well. So we built systems using this architecture pattern, but in 2012, there was an eye-opener for us. One system that we built which followed agile principles, and they had agile teams. But that project went into production after 3 years due to some reason. So we investigated what was the reason behind that. Then we found even they were following agile principles, the architecture was not agile enough to support them to get the production system in a shorter interval, like 3 months or less than 3 years, as they finally went into production. So we thought of we need to address this and need to define a new architecture pattern, and we were experimenting about this thing for a while. Same time, microservices came into the picture as a production ready architecture pattern in late 2012. And organizations like Netflix, Uber, eBay, and eBay started using this thing. But we found a common thing across these organizations as well. Even it was a pure microservices architecture that they used to follow. There was a layer put on top of the microservices. So Netflix called it as APIs, and Uber called them as edge gateways, and eBay used this pattern called API facade. Even Gartner introduced something called mini services on top of the core microservices to address the same problem. And if you can remember, those days, the architecture diagrams look like this. The microservices were stacked in another layer in the typical layered architecture. So it was another form of the layered architecture, didn't move out from that drastically. And we identified a few of our customers improve this thing by moving to a more segmented architecture, by categorizing these services based on the business unit or a specific functional group. And they started building more flexibility and agility into the systems. And some of the customers, they use this pattern called platform of platforms, that they deploy the entire stack per each business unit, that they had a better control and agility within that particular business unit or the agile team. But some of the functionalities like user stores and CI/CD processes were common services that they shared across the business units. But still, it was a layered architecture, and we couldn't achieve what we were looking at that point. So we hit a dead end, and we thought of we have to start this from scratch. So what we did, we started doing a lot of research, and we narrow down our research into 4 areas. We look at the quantum computing, and there were really good concepts came from Kubernetes about decentralization. And interestingly, we looked at biology and system biology as well, because there were some good concepts coming from biology and system biology that directly addressing the end architecture that we were looking to build. At the same time, we looked at the gap between the business and technical services as well. So we identify some interesting things. Now, if you look at the definition, technical definition of a service, it's just a bunch of code annotated and provide an interface that you can access it through a network. Basically, it's a network accessible endpoint that creates based on some code. Now, if you look at the code, it's not a big difference that you will see normal business logic, and then you annotate it and make a service. But business is expecting something completely different. They don't care how you build a service. They look at some kind of a solution for a business problem. And when you try to provide a solution to your business problem, you need to combine these services. And that's where the composite services and gateways came into the picture. So same thing apply for microservices as well. So you use the concept of scope, not the size, because a lot of people think it's a size that you are writing small services to make it micro, but that is not the correct way of doing it. It's basically based on the scope. You divide your the large or the monolith service into multiple services. But if you look at the code, it looks similar to the original service that I showed you. You just write some code and then annotate it, and it will create a service for you. Again, the business definition of a microservice doesn't change from a normal service. Business is looking for some kind of a business capability out of your microservices. So you have to combine these microservices and provide a business capability out of it. So you need to still put a gateway on top of the microservices, or write a composite service. So then the concept behind this, you need to group these services. So the grouping of the services, we call this group as a cell, and then the top gateway, we call it as a cell gateway. So that is how the concept started and linked to the biology as well. So the why we took the biology concepts, because a biological unit is the one built everything that we see in the world today. So we thought of enterprise architecture has the same concept, and we stick to that while making this as an typical architecture pattern. So let's dig in deep into the architecture pattern. And the atomic component of this architecture pattern, we call it as a component. So component can be any runtime that runs in your infrastructure. It can be a database, it can be a service, it can be a microservice, it can be a gateway, it can be a message broker. Anything that you run in your infrastructure, we treat as a component. And the collection of these components, we call it as a cell. A cell contains a cell gateway, and then it has a boundary, and within that cell boundary, you have multiple components running. Then the combination of the cell to the component can vary. In most cases, it can be a one-to-many, that one cell contains many components. And in some cases, it can be one-to-one. As example, if you are running a identity component, or if you are running a message broker, or if you are running a database, it can be one-to-one, that one cell contains only one component. So the cells required to connect inside the cell, as well as out between the cells as well. So we are using this generic concept called a control plane, data plane, and a management plane. And using these three concepts that we are making this communication in between the components, as well as the between the cells as well. So yep.
Your slides are seen only partially. I think it's
Okay.
yeah, I think for some people the view is partial, like they see the screen just halfway.
Okay, I don't know how to fix that.
We will just do like a refresh and present again.
Okay. How about now?
Yeah, looks okay to me. Yeah, I think it's okay to everyone else as well. Okay, perfect.
Okay, cool. I don't know what's wrong with that. Sorry about that.
No problem.
Yeah, I'll continue. So then the inter and intra-cell communication we discussed earlier. So there's a control plane and a data plane local to the cell that we call as the local mesh. And there's a control plane, data plane, and a management plane global to all the cells that we call it as a global mesh. Now, if you are familiar with this service mesh concept, this is more than that. This is service mesh plus plus, because it has a local mesh and a global mesh too. So then the communication.
Sorry, Asanka, I think it's happening again. Thing is, for me the view looks all right, but I think for some they just, when you go like full screen, they seem to only see like partially.
Okay. Can refresh it again?
Yeah.
Is it okay?
It's okay for me. Let me check with the others as well. No, it's still a problem. So
Okay.
there's like a small strip in the corner.
Is it okay now? Then I can like just use this mode.
without going present mode, right?
Yeah.
Yeah, I think we might have to go with that. Yeah, now it looks okay to everyone else as well, Asank.
Okay.
All right, thank you.
No problem. Okay, then the communication to a cell, that there are a bunch of rules here. Any ingress call, that is basically the incoming traffic to a cell, should come through the cell gateway. But egress calls, or the communication going out from the cell, can use multiple cloud native patterns, like a sidecar pattern or adapter or ambassador, and then hit the another gateway of another cell for the communication. So the one rule that I highlighted here, it's basically using the gateway pattern and then hit the another gateway in other cell. So this is API first architecture, as I highlighted earlier. So why I claim that, if you look at the communication between the component, it will happen through some kind of an API, and if the communication between two cells will happen through another API. And it's not only the RESTful APIs. You have the flexibility to use different kind of APIs. So how I categorize them, basically have pull APIs, that is basically RESTful APIs using HTTP and gRPC type of protocols, and then push APIs into two types, like events using JMS, AMQP, SMTP type of protocols, and streaming protocols like Kafka and MQTT. Then as I highlighted earlier, this is using the gateway pattern that will provide a lot of flexibility for us, that since the entire ingress flow goes through the gateway, we can enforce the policies at the gateway level, as well as we can enforce observability at the gateway as well. And the security of the cell is a really important thing, that it can use two patterns. First thing is a self-contained pattern, that within the local control plane, there will be a security token service that provide all the, that will make all the decisions for the authorization, authentication, and entitlement. But in the second pattern, the local control plane will go to the global control plane and get any additional information required to make this security decision. So both are viable. And to optimize the pattern 2, you can cache some of the decisions that you make in the global control plane and make it more, make the performance really high. Then the developer flow of this concept, basically a developer will create a new cell, or they can, if the microservices are existing, they can create cells out of the existing microservices. They can update an existing cell, or they can create a new version of the cell as well. That's totally depending on what type of infrastructure that you are using to deploy your applications. And the developer will not see a difference. He or she will use the same thing that they do in a usual developer flow, that they will build, they will write the code, they will build it, they will commit it, they will test it, and they will push it to the remote repo. And the CI/CD process will either deploy an entire cell or deploy a component inside the cell. And if you are into more container-based environment, you will deploy the entire cell rather than you update a specific component. So this will create more flexibility for you. And then the cell will contain a version, as well as a component will contain a version as well. That will provide a lot of flexibility for you, and we call it as the structured agility, that you will get 3 levels of agility than normal enterprise architecture, that you will have agility at the component level, and you will have the agility at the cell level, and you will have the agility at the enterprise architecture level as well, based on the versioning mechanism as well as dependency management techniques that we are using here. If you look at the enterprise architecture, this is how we envision it. The entire enterprise will be filled with different type of cells, and we categorize these cells into a few categories. The first thing is the logic cells, that those are basically the services, and then you might have integration cells, legacy cells, external cells, so on and so forth. So these are the identified cells at the moment, but you can introduce various other type of cells as well. And this is an example that I'm not going digging deep into this. I'll share the slides and you can take a look. And I claim that this is a vendor and technology neutral architecture. To verify that, this is a reference implementation of that previous slide. And as you see, you can use various technologies to build this particular architecture pattern. And this connects with the team agility as well. And I would say it's a very human-centric architecture that it can connect to the agile teams that I call it as a self-organized team. A cell can own by a single team, and one team can own multiple cells, but multiple teams can't own a single cell. That's a rule that we have defined. And if you are interested about this particular concept, you can read this paper that I published about the cellular enterprise. And if you need to read more about the architecture pattern, this is a article published by a third-party author in Nordic APIs, and you can refer that as well. Then, since you are introducing a new cell, you might need to justify this to your business. There are a bunch of ways that you can do. First thing is you can identify the flow efficiency because now there's more agility. The wait time will be less and the productive time will be high. As a result, the flow efficiency will be improved. And there are other factors like mean time to repair, mean time to detect. Those are really good examples, and the given link provide you more insight into that that you can take a look. So to summarize, a cell is a self-contained unit, and you can deploy it as an independent unit, and you can scale it without depending on other cells, and it contains a local data and a control plane. And as a cell-based architecture, it's a decentralized, microservices friendly, and a cloud native compliant. It's technology neutral, human centric, and you can build APIs as a product using a cell, the concept that Nuan explained in the previous session. So we contributed to this concept in various ways. So we have the reference architecture paper released under Creative Commons. So feel free to send a PR and provide your suggestions. And if you think the architecture document is useful, give us a good star. And as an implementation plan, I have authored another thing called a reference methodology in this particular URL. And you can use WSO2 technologies to build this architecture pattern as components, as well as the integration supporting language that we introduced called Ballerina can use as a way to build network-friendly programs, and Ballerina can be a candidate to build some of these components as well. So if you are interested about this concept and want to convert your current architecture into this decentralized architecture, we can certainly help. You can simply fill a contact us form, and if you want to get some structured consultancy, we can provide it under the strategic consultancy we have, and you can contact me via email, or you can connect me through LinkedIn and follow me using the my Twitter handler. And if you have any questions, I can take a few questions, I believe. If not, please contact me and I'm happy to help you.
I see one question, Asanka. I'm not sure if it's from the previous session. Maybe that's okay. I actually see a few coming in. Maybe you could take them.
Okay, there's a question. Is it practical to have each cell connected with APIs? How many APIs need to manage in large enterprise? What about the observability? So the again, the number of APIs will depend on the size of the organizations as well as the the functionality that you provide. And in our experience, it can vary from 100 to thousands, and it depends on how you structure your organization as well. That's where the concepts like an API store, marketplaces coming in handy, as well as concepts like API products coming in handy as well, that you can combine these APIs and provide it as a product and reduce the complexity. And what about the observability? The observability at two levels, like at the cell level, you can use the observability coming from the cell and captured using the cell gateway. And then those statistics will be published to the global control plane. And using the global management plane, you can track everything that you want to track, as well as you can create any events based on a different kind of policies that you set at the observability layer. And that's a question from Sampath. In a pattern, 2K's control plane will within the cell is using caching. So it's an option. It totally depends on what type of information that you need from your global control plane, the IDP running in the global control plane. So if you can cache any decisions, you can cache it there, and it will reduce the network calls that you are doing to the global control plane, and it will improve the performance. Is there a documentation methodology in my existing layered architecture to cell-based architecture? There's a paper written about the layered architecture and segmented architecture, and in the cell-based architecture, we are briefly addressing how you can move from a layered architecture into the cell-based architecture. There's a concept called monolithic cells that you can kind of wrap the traditional layered architecture components into the cell-based architecture, as well as you can do kind of a migration from the layered architecture into the cell-based architecture by implementing some of the components. Okay, I think those are the questions so far.
Yeah, you covered most of it. Thanks, Lara Sankar. Thank you for the interesting
problem.
session. All right, we've got one more session coming up for you on WSO2 Summit APAC. So for this next session, we will be hearing about unified endpoint management APIs for enterprise devices. So to talk about this, we have a very energetic individual who is well versed in Internet of Things, in API management, enterprise mobility management, and he's in product development, and also the current founder and CEO of Entra. Everyone, please welcome Sumedha Rupasinghe, or your Sumedha.
Thanks, Ashana. Yeah. Okay. You can hear me well, right?
I can hear you well. Yeah.
Okay. Yes. And trying to. Can you see my screen as well?
Yes. Yes, I see it now. Yeah.
The slide deck? Yeah. Okay. Yeah.
Yeah.
Okay. Hello, everyone. Good morning. My name is Sumedha Rupasinghe, like Shara introduced me. So I used to be at WSO2 from 2006 till 2018. My last role there was the director of IoT architecture. And back in 2018, we formed Integra. So I thought like I'll give a little bit of an introduction about what Integra is. So this was founded by the same team that developed the WSO2 IoT and a mobile device integration platform within WSO2. Right? So from 2018, we are operating as a separate company so that we can better focus on IoT and the mobile device management solution that we have. Right? And we are also like subcontracted to serve all existing WSO2 IoT and MDM customers with an OEM partnership, so that we can embed some of the WSO2 technologies within our product stack and further develop the IoT platform and the MDM. And at the same time, if you go to WSO2 for an IoT or an MDM requirement, we will be servicing your requirement. So that's a little bit about the Integra. So the topic that I have chosen today is unified endpoint management APIs for enterprise devices. That is in alignment with the summit's topic. So I thought I'll first define what enterprise devices are here. So first of all, when you take a typical organization, you would see it's very common for employees to use their personal mobile devices or tablets for enterprise work. And at the same time, which is called BYOD, bring your own device. And at the same time, the enterprises would provide devices for the employees to perform certain business related functionalities. Now, this is something that we all know, and we see a growth in this particular usage because more and more employees are working from remote locations, working on the field. Right? So having devices that are mobile is becoming a need. That's one area of enterprise devices. The second area of enterprise devices is the standard IoT devices that we see. So these devices are typically can be sensors that you put in at industrial locations, certain communication gateways that you deploy, or else edge computing modules that are used to collect sensor data, right? And even the CCTV deployments that you see, they fall under enterprise devices because they are part of enterprises business. They help the business to achieve some form of business objective. Now, if I show you some statistics around mobile device adoption in enterprise, right? Now this is on this illustration by Cisco, basically which tells the number of mobile phone usages as of 2020, which we see, which is higher than the people with electricity also. The next slide has the CCTV cameras per 1,000 people based on different cities around the world. As you can see, this is also an increase in number. Then on the third slide, what I have is total number of active device connections worldwide. Right? So these red bar represents IoT devices, right? And the white area represents non-IT devices. So as you can see, like we are here 2020, right? There's a rapid increase in the number of active device connections. So why enterprises are using this many number of devices? It's typically to understand a sixth sense about how the supply happens, how the production of their services happen, and also how the consumption of their products or services happen. So basically using enterprise devices, businesses are analyzing these three aspects about their business: supply, production, and consumption. But this growth is fueled by several factors. First of all, like there's a huge demand to understand more lively updates, more situational updates about the particular business environment, right? So for example, if it's a factory floor, you might want to understand how certain things are produced. If it is a restaurant area, you might want to understand how the lighting is, how good the air conditioning is. If it is a hotel room, you might want to understand the comfort level that the guest is having. Obviously, it's been fueled by the demand, but demand alone will not help it if the devices are expensive. Now, what we have seen during the last decade is a rapid reduction in the cost of these devices. So due to the various advances in manufacturing, the cost of devices have gone down significantly. And at the same time, together with that, the data communication infrastructure has evolved at a rapid level. You see like a lot of new communication technologies coming up. They are being rolled out worldwide. And most of the communication infrastructures are also allowing the bandwidth at an affordable cost, so that you can place devices, connect them, and have the data communication happening at an affordable level. And with this particular setup in picture, there are ample set of software platforms coming up that helps you to connect these devices and develop applications to serve different needs of the enterprise. And there's a different movement to standardize some of the device communication, so that more and more frameworks, more and more developers are interested in developing applications against those standards, so that they can work with heterogeneous devices from different vendors. Now, this particular situation creates an explosion of device endpoints within an enterprise. So what it also means is that the explosion forces you to have these endpoints monitored, managed, and accessed in the proper way. As more and more businesses depend on these endpoints and develop their applications around these device endpoints, it becomes critical that each of these endpoints are functioning properly. So let's talk a little bit about some of the challenges with this enterprise device growth, the number growth. So first of all, we need to understand certain common deployment architectures around devices. So there are certain type of devices that are intelligent and communicable. So typically these type of devices have direct communication interfaces into the cloud infrastructure. So they have their own either SIM, or they are capable of connecting to a Wi-Fi network or a separate radio network. Typically these devices are very expensive because they have a lot more functionality. And the second type of devices are they are typically sensors connecting to a common communication gateway to do communication to the server side that will do bulk of the data processing. That's the second architecture pattern that we see. And between the sensors and the communication gateway, typically this is within a close proximity, so that there are several local protocols that come into play. Then the third common type that we see is devices connecting to an edge computing gateway that will do some processing on the data, and then only push the processed data into a cloud platform for the further processing. There are different sub patterns, but these are common patterns at a high level. Now, this deployment patterns together with the number of devices creates a huge number of challenges to the enterprise to manage. Okay? So we spoke about heterogeneous deployment architectures, But what it also means is with that particular deployment architecture, the traditional corporate network boundary is now getting expanded. Previously, you could be having all your devices that your business requires within your premises or within your factory premises. Right? But now what it means is if you are shipping out a particular sensor with the product that you're producing, and if it goes to the consumer's home or like consumer's location, what it means is now there's a sensor connecting to your network from a remote location. Same case, if you're having a corporate office somewhere and your factories at different locations, and you deploy a sensor network to understand how your factories are performing, how the supply, production, and consumption happens. Now, your network is now expanded, which means the network admins now have to worry about that those devices are connected properly, they have proper connectivity because your business now relies on it. And at the same time, you have to determine this functional accuracy coming out of the device because your business functionalities and logic is depending on top of it. And since the devices are devices are at remote locations, there can be situations, some devices going rogue. So this is something that you need to detect, right, as part of your device endpoint management. And since the devices typically come in large numbers, and typically these devices would have either a human owner or a human operator, right? You also need to worry about identity and access management for these devices. So when we hear about IAM, typically we talk about humans only, right? But it's a problem that is applicable for the devices as well, and it usually comes in large numbers compared to the human identity access management problem. And once we have remote device deployments, okay, have the ability to connect to these devices so that you can keep them updated, you can update the firmware, right? Is an essential task because like it's very common for your processing logic to change, or it's very common that the device manufacturer discovers a particular issue and they want to roll out a firmware update. So what it means is if you're having thousands of devices, you can't be sending somebody physically to go in and plug a cable to the device and update it. Your enterprise network now should have functionality to roll out a firmware update, right? And also schedule it so that it will not disrupt the normal operations. Then once you have the devices working, you need to have standard integration application development interfaces so that your developers can make use of these devices and develop things that will be useful for the enterprise. And of course, like before devices come into the picture, the device picture of a proper installation, it goes through several other phases, which we are going to talk here. So a typical device goes through several phases. So first of all, it is getting manufactured at a factory. We call it device manufacturing on this slide, right? Then typically once a device is manufactured, it goes into a testing phase within the factory premises or within the manufacturer's premises so that they know it's working. Sometimes you may have seen certain stickers called QC on devices, which tells that it has gone through quality control or quality checks. And then once the device is ready to be sold, right, it goes into, so there are different phases where it is sold into a customer, so that from the CRM, from the sales system, it gets allocated to a particular customer so that it no longer is available for another sale, right? And then it gets delivered. So it can be on the road for like several days or like weeks, right? And then the device gets installed. So typically when the device gets installed, the operators, the servicemen right? We'll do certain quick checks to make sure that the installation is done. So we typically call that installation verification. So once the device is properly installed, it goes into the production, right? Where within the production, it can be performing normally, it can go into unreachable stage, it can be producing degradable results or going rogue. Okay? Now, those are critical set of life cycle stages within the production, sub life cycle stages, I would say. Now, typically a device would spend most of its lifetime under production stage. Okay? And time to time, it may go into the life cycle state of being listed out for firmware updates. And also if it becomes faulty, getting into a situation where maintenance is required, or it is going rogue, somebody steals it, somebody does some manipulation, and finally being discarded. Now, in each of these phases, there are different integration requirements. Okay? So this is where the endpoints, API endpoints come into the picture, because each of the device class or device type is unique, right? And you can't expect an average programmer to understand all the protocols, all the technicalities behind a device, right? And be able to produce application logic or software programs that can connect to those devices and produce some business functionality. Typically, that particular skill set it spans around a vast set of technological areas. So the importance of having unified set of endpoints to represent devices, to represent different stages that a device goes through, comes handy in this situation. So for example, in the situation of a device being manufactured, right, typically the manufacturing system would request or the next serial ID to be embedded into the device, or else it could be burning a MAC address that needs to go into the inventory system of the company's sales process, so that they would know a new device with a new MAC address have been added in, so that the inventory goes up. And typically with the devices, there's something called provisioning token or a certificate, a way of like authenticating a device when it is being installed. So those type of tokens and certificates needs to be generated from a software system and should be obtained via an API into the manufacturing system, so that it gets burnt into the ROM of the device. So for all of these integrations to happen, APIs are a critical factor. And once the device is like ready, it's manufactured, you typically would have quality control, like I've said before. So what it would mean is like there will be testers who would be doing certain things on top of the device, and then they would have a separate testing application that would allow you to wipe off the device so that it can be factory resetted, so that it can go into the customer, which is like ready for sale, or it will go into the warehouse and it gets sold to a customer, then being delivered, right? And once it's installed, it's a typical device operation where device is now sensing or providing you ability to control the business environment. And typically at that particular stage, like integration with warranty systems, activating a digital twin type of integrations will also happen with external systems. So what we have done here is within the Integra platform, this was formerly known as WSO2 platform, we have integrated set of known WSO2 technologies like the API management, some of the event listening capabilities, some of the data analytics capabilities, identity and access management capabilities into a single product called Integra IoT platform. And on top of it, we have created certain standard APIs that will allow you to access different stages of different devices. so that you can develop your applications, develop your business functionality on top of those APIs without having to worry about certain specifics about devices. And when we talk about it, typically due to the heterogeneous deployment architectures that I presented before, we talk about 3 layers. We have software components going into these 3 layers. To the devices, we have firmware for certain specific device platforms, right? Or else we have SDKs. And we also have certain limited processing functionality that can be embedded into small computing devices. We call that our edge computing module, right? And a fully blown infrastructure, server-side software that can deal with the incoming events and then either expose them as APIs or put it into processing, analytics processing, or else create complicated integration scenarios while maintaining the access, identity and access management scenarios intact. So I have a couple of screenshots to show what we have done. Now, for example, this is the API management component running inside the IoT platform, so that we can provide managed API endpoints for the devices. As you can see, like it's a fully blown API store with certain predefined APIs. And on top of these APIs, we have created our own device management console. Right? So if somebody wants to use the product as it is without connecting to the APIs, they can have comprehensive set of device management functionalities to manage these unified endpoints through a single platform. So what it means is you can have a single device management console for different types of devices coming from different vendors for your enterprise, so that you don't have to go into different applications to understand how one cluster of devices doing versus the other cluster of devices doing. And for certain known device platforms like Android, iOS, Windows, Linux, we have certain specific APIs that are dealing with their specific nature. And at the same time, for generic devices that you want to onboard, we have a generic set of APIs that, for example, allows you to connect a device, push an operation, understand what the device is going through. So there's a generic API for that. And also, like there are APIs for different stages of the device. If you want to search for all the onboarded devices, there are different device API categories. And the next most important thing is, like I've mentioned, the firmware management. So there's a generic firmware management functionality that we have provided, a console and an API, so that you can write your extensions to deal with your type of device to get firmware updates through your own broker architecture. And then there's a firmware store as well that you can customize to get the required functionality. And on top of this, the IoT platform, we have created a specific solution for managing mobile devices, the traditional mobile devices that you see, Android, iOS, Windows type of mobile devices. So it's a specific solution that is available if you are looking for managing the standard mobile devices only. And more documentation is, details are available at the documentation. So this brings us to the end of this session. We wanted to give you an overview of some of the unified device management APIs that are available within the Integra IoT platform. So if you are interested in understanding how this can work for you, because typically IoT architectures are complicated compared to other systems, please drop us a mail at contact@integra.io, and we would happy to understand your requirement and propose a POC and a high-level solution architecture, so that you can see how you can make use of our unified APIs to access your heterogeneous device deployments in a standard way. Thank you. If there are any questions, would like to answer.
Thanks, Sumedha. I'm just checking Q&A. I think some of the questions were already taken. What we were able to answer, maybe we can just give a few seconds, and we could, maybe in a bit, we could move on to the next one. Actually, Sumedha, what I'll do is, if there are questions, if questions come our way, I'll send them to you so you can take them on directly. Is that okay?
Sure. Yeah, sure. I see.
Yes, actually, I see one as well. Okay, there are some coming.
So in terms of protocols, there are standard set of protocols that we support, starting from HTTP, MQTT, CoAP, the different set of protocols. But at the same time, this is built on top of the WSO2 integration architectures, which means you can write your own adapters if you have custom protocols. With the question on updating firmware through APIs. Now, this is something that can be very tricky if you don't, if you are not working with a standard device platform. Now, for example, in the case of an Android device, there are a lot of Android-powered devices that are non-mobile. Right? Now, in the case of Android has a standard way of accepting a firmware update and making sure that it is applied on the device, and you can even roll back. Right? But now, if you are working with a custom device, you need to, within your device OS or device firmware, you need to write the logic to accept a firmware, accept a configuration file, and keep it in a separate space, and then apply it and boot it up. And typically, like if you are having a very low footprint device, you may not be able to do that. So there can be situations where you want to have two separate ROMs. One is running the current firmware, and the other one getting the newer version, and then ROM switching whenever there's an update. So it's very device platform dependent.
Cool. I think we can wrap up the session. All right. Thanks, Sumedha. So that almost brings us to the end of day one of WSO2 Summit to APAC. It's been a very good day with lots of interesting sessions, and we thank all of you that was a part of it, sending in your questions and things like that. But tomorrow is also going to be equally exciting with more sessions coming up. And to tell you more about what you can expect tomorrow, I'm going to hand over the controls to Shaveen. He's the Associate Lead Account Manager and Territory Manager APAC for WSO2. Over to you, Shaveen.
Thank you, Ishara. So good morning, afternoon, and evening, everyone, wherever you are in the world. I guess we've come to the end of the first day of the summit. First and foremost, thank you for taking the time to be a part of this year's summit. The second virtual summit for the year and the first for this region. I really hope you found it interesting and productive, and I certainly hope that you put your learnings into test as soon as you do get the opportunity. I'm going to take a minute to thank our speakers today. So a very big thank you to Sivan Umapati, CIO, Telecom Malaysia, Akash Saxena, Vice President, OCBC Bank, Sumedha Rubasinghe, CEO, Integra, one of our very own, and everybody else at WSO2 who made this a possibility. So I'm sure the experiences are a testament to what we could achieve in a constantly revolving world. And in case you're one of them companies or individuals that craves for that kind of change and you want to break barriers, do get in touch with us. We'd love to be a part of that journey. Before we wind up, I'd like to give you a quick overview about tomorrow's agenda or what you should expect tomorrow. We've got some very interesting topics lined up. For example, moving away from supply chain to value chain, creating an API marketplace, CIAM and other security aspects, related to these topics. We've got fintechs and other customer experiences, cloud native architecture, and most importantly, 2 customer success stories from the government of Bhutan and Aditya Birla Finance from India. It's been quite a long day, I assume, and I wouldn't want to keep you waiting any further. We'd absolutely love to see you first thing tomorrow. So grab yourselves a drink tonight, a drink of your choice, of course. Reflect and come back with plenty of energy as we have some very interesting sessions lined up for tomorrow. Thank you and stay safe.